Thanks for coming, Avi.
My great pleasure and privilege.
The audience should know up front that Neil deGrasse Tyson attacked you out front of your hotel last night. And,
not really. I'm a pretty tough guy. I jog every morning at sunrise, but I tripped on a pipe of sprinklers as I arrived at the hotel, and that's why I got bruised. Now, the cover story could be related to a NASCAR car race because just a few weeks ago, I attended a car race in Bakersfield, California, where one of the racers decided to put my image along with 3i Atlas on the hood of his car.
That's fantastic.
And so when I got there with the Netflix documentary team that is making a documentary should come out in 2026 about my work, the racer put me in the car after I signed my name on his T-shirt and showed me how to drive it. So then he invited me to go to Daytona. And my wife said, no way, you're not taking that risk.
Yeah.
So, it would have been worse if I were to participate in Daytona. And one interesting insight that I had during the car race is I wondered, why isn't there a corporation that makes a self-driving car that will win the NASCAR? I mean, that's obviously doable. And my answer is that we enjoy watching humans compete.
Yes.
And, computers are able to do better than humans on chess. And by now there is art that is definitely competitive with human-made art. Nevertheless, we don't pay much for it. And the reason is that we enjoy the human connection. And in sports, we don't want to see a robot that outruns the best athletes. And the same would be true with art, that art is a way of communication among humans, and therefore, AI will never substitute for a human touch.
Yes. And the other thing is risk. If there's no humans in the cars, there's no risk. No, the risk reward, right? The more risk, the higher the reward. And it's just like with doing anything.
Exactly.
Even creating art or whatever, you risk spending the time to create something, putting your life in danger to race this car. It makes it more entertaining and more thrilling and exhilarating to witness.
Exactly. It's the human spirit that brought us to the moon, and my hope will bring us to interstellar space.
Yeah, we were just talking about the moon before we started recording. I was telling you about my recent podcast with the Apollo astronaut and the moon landing skeptic. And the moon landing skeptic had a plethora of incredible claims and facts that he brought to the table that the astronaut really couldn't compete with.
Well,
fair enough. I mean, you have to consider the fact he's 90 years old. It was a long time ago when he went to the moon. He may not have the sharpest memory, but he does have some memories. But
there is a very good argument that, to convince anyone, and that is there are retroreflectors. These are corner reflectors that were put on the moon and were used over the past few decades to bounce laser beams off them so that we can gauge the distance to the moon very precisely. And in fact, that was used to imply that Newton's constant doesn't change in a trillion years. By one part in a trillion, it doesn't change. So over 1 year. So these retro reflectors are there. We can use them to bounce laser beams. They were not there by any alien civilization. We put them there.
Couldn't we put them there with rovers or machines?
Not really. So there was a moon landing. Of course, we have also samples that were brought back to Earth, but you might argue maybe these were found on Earth.
Von Braun picked them up in Antarctica. In 65.
But these reflectors were, and there is also, I think, an American flag on the moon that you can find. So my point is there are things on the moon that were definitely put back then that wouldn't be there otherwise.
Well, I do understand the argument that one of the big questions is why haven't we been back? And it does make sense to me why we wouldn't need to send people back, right? Because it's like, again, to our original conversation about NASCAR, it's too much of a risk to send humans way out there when we can do it just as good of a job with robots.
Right. For science, definitely it makes sense to send robots because humans are more vulnerable to the harsh conditions in space. Also, we haven't used AI in space as of yet. And it would be necessary if we take long trips, because right now, all of our missions on the Mars or the Moon are being helicopter parented by engineers in the Jet Propulsion Lab in Pasadena. So, and I say helicopter parented because there is a helicopter that was parented on Mars by these engineers. And the point is, if we send a mission to a much more distant destination, then we can't really provide guidelines to these probes, because it takes a long time for light to cross that distance. For example, Voyager now is one light day away, and Voyager just started in the 70s. Now, Voyager will exit the solar system in 10,000 years through the outskirts of the Oort cloud of the solar system, and it will take several years for a signal to get there. And if it reaches the nearest stars, it may take even longer. And so the point is, if it faces some immediate decision to be made about what to do under some circumstances when it lands on a target, those decisions cannot be made by engineers on Earth. They have to be made by the probe itself. It needs to be autonomous. And that means it needs to have its own brain. And it would feel like sending kids out of your home when they are autonomous. They can make their decisions. That's what happens after a certain age. You send off your kids, and every now and then they send a postcard or report about what happens to them. And so we will get reports from those very distant probes that we send, but we will have to rely on them doing their job according to the guidelines we gave them. And that requires AI. And we haven't used AI as of yet on a spacecraft. That will be the next frontier.
Using AI on a spacecraft.
Yes.
So going back to the moon real quick, what is the most practical use for us, or the most practical reason for us to go back to the moon or study the moon? What use to us is the moon, other than its obvious, like being the gravitational and moving the tides and keeping us in this protocol?
I should say up front that I'm not hugely excited about the vision of going to the moon and Mars as the ultimate, destiny of humanity, because, these are rocks that are not better than Earth. Earth is a paradise.
Yeah.
It has an atmosphere, liquid water. We feel comfortable here. We better preserve it as much as we can. But if we ever want to put a significant fraction of humans out there, we better build a space platform that can accommodate them, that will have its own energy source, for example, nuclear reactors, will have its own habitat, and its own gravity based on rotation. You can produce, if the spacecraft rotates, you can produce a centrifugal force that would mimic gravity. And so, in principle, one can come up with a concept. Now, you might say it's very expensive, but think about the fact that we're investing $2.4 trillion a year in military budgets worldwide. And if we decided to allocate a significant fraction of that to space exploration, we would spend $1 trillion a year, meaning that it would be a super Manhattan Project size ambition that the best architects, the best technologists, the best scientists will be engaged in. And I believe that if with $1 trillion a year, we can actually build a spacecraft, we can move to space in a way that is much better than relying on a rock that existed for a long time and using missions that cost billions of dollars instead of trillions of dollars.
But how big could this thing possibly be? Like, how many humans could it fit? And would it be cheaper than building like an underground city in a cave on the moon?
Oh, well, that can be done. And also on Mars, you can, in principle, use a cave or a...
these lava tubes, right?
Exactly. And what I would like to find out is if we enter one of these lava tubes, whether there are any prehistoric paintings there, because maybe someone else went there before us, especially on Mars, which for half of its lifespan had conditions very similar to Earth. There were lakes, oceans, rivers of water there, and we just don't know if intelligent life was twice as fast in developing on Mars than on Earth. All you need is a factor of 2, which is not very big because, we exist 4.5 billion years after the Earth formed, and Mars, if...
we were very late on Earth.
We are very late. By the way, if you want to get a good dose of modesty, then you have to realize we are not at the center of the universe. We know that since Copernicus and Galileo, despite the wishful thinking of the Vatican. But we also came very late to the cosmic play. Only over the past few million years, the human species came to exist. And the universe existed for 13.8 billion years. So the conclusion from that is if you arrive late to the play and you're not at the center of stage, the play is not about you. It's a very simple conclusion. And you better find other actors to ask them what the play is about. We have very limited knowledge of what happened to our cosmic neighborhood before we came along. I mean, we have some indirect evidence, but documented human history is only 8,000 years old. And so much has happened on Earth. We don't even know if on Earth there was a very advanced civilization before ours.
Right.
That may have, created self-inflicted wounds and died, they perished, And also it's quite likely that all the civilizations elsewhere in the Milky Way galaxy, if you ask where is everybody, like Enrico Fermi asked, they're probably most of them are probably dead. Because if you ask, where are most of the humans that lived on Earth? There were more than 100 billion of them. And now there are only 8 billion, they died. Okay, so most civilizations died billions of years ago. We were not around to witness their pain, their struggles, their history. And the question is, if we want to be remembered in the history books of the Milky Way galaxy, we need to do one thing, not stay on this planet. We need to build monuments in interstellar space that will maintain some memory of us. And I don't mind if humans are on these monuments. What I call monuments are basically spacecraft that go to interstellar space. It could be with humans, it could be with AI. I don't mind. The point is, we want anyone else in the Milky Way galaxy to know that we existed or to remember the guiding principles that we cherished. And if we stay on this planet, we might survive another million years, maybe a billion years, but not more than that, because the sun will brighten up in a billion years and basically boil off all the oceans on Earth, all the liquid water, and the Earth will become a desert, just like Mars. So we have 1 billion years left, about 20% of the age of the Earth left for us to do something about it. If not, nobody would mourn the fact that we died. We can disappear from the surface of Earth. There is nobody in the cosmos that will hold a funeral or say good things about us unless we take our fate into our own hands. And you said early that humans are known for taking risks and having the human spirit. So I think the best way of displaying it would be to become an interstellar species.
Yeah, if we got wiped out and there was another civilization of humans popped up a million years from now, they might see like the Hoover Dam and the Washington Monument and be like, whoa.
Even that may not be visible if there is enough dust from asteroids impacting the Earth. And yeah, I mean, but the point is that we are very short-sighted, because if you look right now, we are engaged mostly in conflicts. We live for a short time, each of us, just a century.
Territorial apes.
Yeah, and we invest most of our time in either shortening the lifespan of other humans or preventing them from shortening ours. Like, this is completely non-intelligent, okay? So my hope is, and that's the main reason I'm working on interstellar objects, my hope is that we will get a package from another civilization in our mailbox that will imply that we can do better. And we might want to imitate them, those that arrived to our backyard before we arrived to their backyard. And, it's just like finding a sibling of your family that you didn't know about that is more accomplished than you are, and therefore you get inspired. As Oscar Wilde said, imitation is the sincerest form of flattery. So in that context, for example, I studied the interstellar objects for 8 years now. And the SETI community that is looking for radio signals was very critical of this work, and still is. And they were banning any discussion about technological gadgets near Earth in their conferences. But recently, just a few months ago, they wrote a paper, some of these people, in which they say we need to check if interstellar objects might be technological. And again, imitation is the sincerest form of flattery. I don't need them to give me credit. I just realize that when they do what I do, it's actually a compliment.
It's holiday season, which means it's time to figure out new ways to hide your receding hairline from your extended family. We know red light therapy heals, and we also know that there's hairlines out there that need healing. So iRestore said, let's fix this. The iRestore Elite is clinically proven to help regrow hair using 300 lasers and 200 LEDs that send light therapy directly to your scalp. In a double-blind clinical study, nearly every participant saw an increase in their hair growth with this technology. The iRestore Elite uses VIXO lasers that feature wider beams of red light wavelengths that reactivate dormant follicles to restore your natural hair. And the LEDs provide a broader uniform coverage to fill in the gaps. And it all comes with a fantastic money-back guarantee. It's comfortable, it's lightweight, it looks badass, and I don't feel goofy around people when I wear it. In fact, I can't keep people from wanting to borrow it from me. I've talked about red light many times before, so this technology is very reassuring. For maximum effect, bundle with the Revive Plus Max Growth Kit and biotin gummies, which work great with the red light wavelengths. Holidays means get-togethers, photos, and wanting to look and feel your best. iRestore is here to help with huge seasonal savings all month long. And with code DannyJones at iRestore.com, you can unlock an exclusive discount on the iRestore Elite. That's DANNYJONES at the letter iRestore.com. Please support our show and tell them we sent you. Yeah, there's been a lot of pushback on the 3i Atlas stuff, and I want to get to that in a minute. But like going back to the Mars stuff, do you think it's possible that there was a point in history where Mars was habitable for life and had a more robust atmosphere and a place where humans could thrive?
That. Yeah, definitely. We know that the conditions were similar to Earth. In fact, for about at least 2 billion years, if not 2.5 billion years, which is half the age of Mars. Mars lost its atmosphere only in the second half of its history. And it's not obvious what the trigger was, but presumably it didn't have a strong enough magnetic field to keep the atmosphere bound, and perhaps the solar wind ripped it apart. And we just don't know the details. But there is definitely clear evidence that there was liquid water on the surface, and it was a place similar to Earth. Now, in fact, it started before Earth because it's a smaller body. So the cooling of a body is proportional to the surface area. It stores some heat from the formation process, and then it cools from the surface. And the amount of heat that is in it is proportional to its mass or the volume that it has. So Mars is a smaller body, therefore it had more surface per unit mass. So it was easier for the heat to leak out from a smaller body than Earth, and therefore it had life probably before Earth. And therefore, at that time, in the first hundreds of millions of years of its lifespan, after it cooled enough, it could have delivered life to Earth because there were rocks that were basically making the trip from the surface of Mars to Earth as a result of an impact by a bombardment by some asteroids. We know that there were lots of bombardments, and we have one rock that was analyzed about 45 years ago from Mars, and it was possible to say that this rock was never heated to more than 40 degrees Celsius during its entire journey from the surface of Mars and passage through the Earth's atmosphere, created a fireball, and then landing on the Earth. The core of the rock was never heated to more than 40 degrees because it has magnetic properties that would have been erased if it were to be heated by more. And that means that microbes could have survived at the center, at the core of this rock that we have an example of. And the same is true for the rocks that came early on. So it's possible that microbes were the first astronauts, really, that came from Mars to Earth. And when Elon Musk wants us to send astronauts to Mars, that will be just like returning to our childhood home in a way.
Is this disputed and contested at all that Mars was once inhabitable for human beings and had an atmosphere?
Human beings is a
water?
separate matter, but for microbes, definitely.
For microbes,
we don't
it was
have
very similar to Earth.
Yeah, similar to Earth. Now the question is whether intelligent creatures existed on Mars after 2 billion years. On Earth, definitely not. We didn't have that. But if the evolution of life was accelerated for some reason on Mars by a factor of 2, that's the only thing you need. Then you could have had intelligent creatures over there as well, and they were wiped out. It's obviously for the same reason that we will be wiped out in 1 billion years when all the liquid water on the surface would be gone.
Well, it's interesting. There's that element, the xenon 129, that was found on Mars, and the only place on Earth it's actually found is like ground zero of the tests of thermonuclear bombs.
That's interesting, yeah.
So wherever there's nuclear explosions, where we've tested nuclear bombs on land, we find this xenon 129.
Interesting.
And that seems to be that, I guess it's an isotope, and that was found on Mars. And it's
imagine a situation where there was a population there that went into a nuclear war and wiped itself.
And it's not so the xenon 129 is not a naturally occurring phenomena.
That's interesting.
It's only allegedly created where there's nuclear bombs, and we found it on Mars. Did we detonate a nuke on Mars?
We never did that, of course.
Right.
So that's an interesting clue, because you can't make isotopes easily without the nuclear process.
Right.
It's much easier to do chemistry on the surface of planets than nuclear physics, because it requires much more energy density you can't really have the high temperatures needed to produce isotopes of this nature. So that's interesting. Maybe something happened on our neighboring planet. But that doesn't mean that we need to go there. I mean, we can go there as archaeologists to survey the land and figure out what was there to start with. And, there could have been also... Mars right now is like a museum, because if you imagine a rock that is roughly the size of a person impacting Earth, and by the way, that happens once a year or so, a rock of about half a meter to a meter in size. What happens to it, it usually burns up 50 kilometers at a 50 kilometers altitude, and there is not much impact on the ground because it's way up there. It releases as much energy as the Hiroshima atomic bomb. And we just don't hear about it in the news. Every year there is something like that. Except a much bigger rock can penetrate through and reach the ground, and then you get some major effect. But most of the time, 71% of the Earth is ocean, so you don't.
Right.
But nevertheless, these things happen all the time. But the point is that on Mars there is no atmosphere, so such an object will reach the ground, and Mars is like a museum. It collects everything that impacts it. At least over the past 2 billion years. Before that, it had an atmosphere, and so we can look at it as a museum and check, whether any technological objects impacted Mars before we came there. Nobody is planning right now to do it. NASA is mostly interested in microbes. Astronomers are mostly interested in microbes. The decadal survey of 2020 defined, in astrophysics and astronomy, defined as the highest priority searching for the chemical fingerprints of microbes in the atmospheres of planets near other stars. That is the highest priority, with an investment of about $10 billion over the next 2 decades.
So we haven't found any evidence of life on Mars yet?
Not yet.
Okay.
I mean, the most recent clue is these rocks that were discussed in a recent press conference, where it looks like they have some residue that could have been from microbes, but to be sure about it, that it's not geological effects that produce those residues, we need to bring these rocks to Earth and analyze them to make sure that it's not something geological, but rather biological that created their appearance, which resembles rocks on Earth with microbes on them.
Would that be a difficult thing to do, to bring big rocks back from Mars?
No, it's not difficult. It's just it costs money.
Right.
That's called the Mars Sample Return mission that was originally planned, but because of the cost, was sidelined, but now Mars is back looking into cheaper possibilities of doing it. And I think it's really fascinating. Another comment on this is that, and that was never discussed, is that now we are starting to find interstellar objects, meaning objects that came from other stars and reached the inner solar system. And so even if these are just rocks, if we were to design an interceptor, a mission that lands on such a rock, brings a sample back to Earth, we would be able to study the building blocks of potential life around other stars. I'm saying even if it's just if 3I Atlas is just a natural rock, just imagine a rock the size of a city. We know that it's about 5 kilometers or so, or maybe even bigger. First, it's a big object. Second, this one actually moves in the plane of the planets around the sun, which offers an ideal opportunity for us to intercept it and land on it. However, we didn't know about it in advance. I calculated, I wrote a paper that I published shortly after it was discovered, that in fact, there is a spacecraft around Jupiter called Juno that was launched by NASA. And if they kept the original fuel that it had, they could have used it to intercept, to actually collide with 3 Atlas on March 16th, when it will come closest to Jupiter. But they used most of the fuel, so they can't do it. But it illustrates the fact that if you detect an object like 3 Atlas early enough, you can intercept it or land on it. And
how fast is that 3I Atlas moving?
It entered the solar system at 60 kilometers per second. So coming back to the NASCAR race, it's faster than the fastest car we have by a factor of 600. 600 times faster.
And you can land on that?
Well, it depends how you design the interceptor. I mean, you can definitely cross its path, but then obviously the spacecraft will be demolished as a result of the impact. It could send us close-up photographs.
Right before it gets incinerated.
But there are also situations where, for example, if the interstellar object comes on an orbit that is not that fast and actually goes behind the Earth, then it would be relatively easy to land on it, bring something to Earth. So my point is, this is a frontier, a window into the universe that was never explored, because astronomers always focused on remote observing, using telescopes to look far out. Nowadays, we also use gravitational wave detectors to look at the universe. It doesn't matter. In both cases, we're looking at very distant sources, trying to infer what is out there. It's just like you are in a home, in your home, at a house, on the street. You see many houses similar to yours, and you look at them through the window with telescopes, let's say. So you can learn if they have microbes, for example. But it's very different than getting a physical object that came from a neighbor's yard that you can study. If it's a rock, you can learn what the neighbor's yard has. If it's a tennis ball that was thrown by a neighbor, you can learn about the neighbor. And maybe the neighbor will come and knock on your front door. That's the other possibility that we have to contemplate. We haven't really considered what to do if there is a visit by alien technology that could pose a threat to humanity. People would say it's very small probability that this would happen. First, they don't know how to calibrate. We don't know how much traffic there is of interstellar technological objects. But secondly, we don't have a protocol for how to deal with that. And, the intelligence agencies always have a protocol for how to deal with black swan events. These are events that have small probability but big impact on society. And the reason you need to deal with them is because even if you say it's unlikely, the impact would be huge. And therefore, you must have a way of collecting information that would basically neutralize the threat. And serious people in government, in the intelligence agencies, always spend a lot of resources on events that never materialize. We don't know about it. They may have prevented some disasters, like terrorist attacks. But it's part of the rational thing to do. And scientists, on the other hand, do not understand that, because if a scientist says At the 99% confidence, I know that 3i Atlas is a rock or a comet. Even if you say that at the 99%, fine, that is okay when you deal with interpretation of events that have no impact on society. Like you deal with a galaxy far away, an exploding star far away, no impact on our future. However, when you deal with something coming to our backyard, you can't just say 99%, it's a rock and therefore we shouldn't even worry about it. Because if you take the 1% chance that it might be alien technology and multiply it by the potential impact on the future of humanity, you get a huge number. So what you have to do, our duty as scientists, is to collect as much data as possible to figure out whether there are any anomalies, anything that looks strange and we can't explain it, that might be indicative of technology. And that's my point. My point is we have to mature, scientists have to mature and realize that in this case, there are political, financial, societal implications, and therefore they cannot use the procedure of saying at some high likelihood this is well understood. And that's what NASA did basically in a recent press conference. They said, it's a rock. It's a rock, don't worry about it. The point is that the nature of the object should not be decided by NASA officials. It should be decided by scientists that analyze the data. And I would much rather have, at this press conference, scientists talking about it and explaining why this or that facts are indications that this is not technological.
Anytime I'm doing hard work outside, Brunt's Marin work boots are my go-to. If you've worn bad work boots, you know all about the painful break-in period. But right out of the box, these Marin work boots are already comfortable and they flex as if they're already broken in. No more limping around for a week hoping they soften up. Just straight up comfort out of the box from day one. Eric Girard founded Brunt after his work friends complained that their boot construction hasn't changed since the 1920s. Brunt's boots are not just comfortable, they're built to perform. It's lightweight, waterproof, slip resistant, heat resistant, and even electrical hazard rated. Basically, whatever the job throws at you, these boots can handle it. And the best part is, it doesn't hurt. I can't stress that enough. Brunt's got over 500,000 workers backing them up, and you can send them back if you don't like them. That's how confident they are. So if you're tired of boots that destroy your feet more than the job itself, it's time to check out Brunt Workwear. Your feet will thank you. With temps dropping and holidays coming up, it's time to treat yourself or the hardworking man in your life with real comfort. Skip the throwaway gifts and get him something built to last. Brunt Workwear. Our listeners get $10 off their entire order by using the code Danny at checkout. That's bruntworkwear.com and use code DANNY. Order today and let them know we sent you. Thank you to Brunt for sponsoring this episode. So for people who are normies like me, and I doubt there's many that don't know what 3i Atlas is, but can you explain just give us a basic rundown of what exactly it is and how you discovered it? And why is it called 3i Atlas?
I didn't discover it. I just paid attention to it.
Okay.
So 3i Atlas is the third interstellar object. So that's why you have 3i. Atlas is the name of the telescope in Chile that discovered it, only 0.5 meter in size. Every day now, when I write on medium.com and reports about 3i Atlas, and every day you can see images of 3i Atlas taken by 0.5 meter telescopes that are owned by amateurs, with at a cost of, thousands to tens of thousands of dollars. Compare that to the instruments used by NASA that cost altogether billions of dollars. Nevertheless, the information in those images taken by amateurs now is much greater than in the NASA images at the press conference that we heard about. But 3i Atlas was discovered on July 1st, and it was very bright. And July 1st is just 3 days before the July 4th holiday. Mm-hmm. That's important because my wife wanted to go on a vacation, and I immediately realized this object is bright. It's the fact that the 0.5 meter telescope saw it at a distance of 4.5 times the Earth-Sun separation means that it's a very bright, very big object. And I calculated that if it's the brightness of this object is as a result of reflection of sunlight from a solid body, it has to be 20 kilometers in diameter, which is the size of Manhattan Island, the length. That's a huge object. That's comparable to the size of the asteroid that killed the dinosaurs 66 million years ago. These are extremely rare things. So then, as we got to the vacation place, I immediately did a calculation and argued that there is not enough rocky material in interstellar space to deliver such a big package over the past decade, because this survey went only for 1 decade. And you would expect it once per 10,000 years. Now, you might say, oh, well, maybe it's a rare object that happens to come by. That's obviously possible, but at a probability of 0.1% or so, or less. And then, so that was the first anomaly that struck me.
The size.
The mass. So it's a million times more massive than the first interstellar object discovered in 2017 called Oumuamua. That was the size of a football field. So compare the size of a city to the size of a football field. That's the difference in size. And the mass goes like size cubed.
And how do we determine that mass again? What is the calculation there?
Oh, it's just you take the size, the diameter, let's say, and cube it, multiply by the typical density of a solid, and you get the mass. And in both cases, and irrespective, if you use the same density for both objects, which is solid density, about 1 gram per cubic centimeter, you get a large size of order 5 kilometers or bigger for 3I Atlas. So it's at least 1,000 times more massive than the second interstellar object called the Borisov, which was found back in 2019, and 1 million times more massive than Oumuamua, which was found in 2017. So that's, by itself, it's an anomaly. Why? Because I wrote in my paper, I said, either the object itself is much smaller than we think. Maybe there is a very dense plume of gas and dust around it that reflects sunlight, and the object itself, the nucleus, is much smaller. That would be that would relieve the tension in terms of the size or the mass. And the second possibility is that if it's so big, maybe it targeted the inner solar system. It was not drawn from the reservoir of rocks in interstellar space. And this was my last sentence. Maybe it targeted the inner solar system. The editor of the journal, and that was just a few days after the object was discovered, the editor said, I will publish this paper only if you remove this last sentence.
They said that they would not publish it unless you removed the last sentence.
Yes. Basically, you shouldn't say that it was targeting the solar system as a possibility. It's definitely a comet, according to the editor. And that was just the early days. We didn't have much data at that time. Just to show you how science operates these days. So I said, okay, well, I want it to be published. So I took out that sentence, and then, the rebel that I am, I wrote a full paper on the technological option. And in that paper, in collaboration with 2 other authors, that was peer-reviewed and published, just to show you that this editor was out of line, because this paper was eventually published, peer-reviewed. And we showed that also, the fact that it was targeting the inner solar system is supported by the trajectory, which is aligned with the plane of the planets within 5 degrees. And the chance of that happening at random, if you consider all incoming orbits, only 1 in 500 will be so aligned with the planets. And
1 in 500.
Yeah, and this is the third object. So, again,
we've only been monitoring these interstellar objects for how long?
About 8 years.
About 8 years.
Yeah.
Okay. So since about roughly 2017.
Yeah, 2017 is when the first one was discovered by a telescope in Hawaii that was looking for
Oumuamua, right?
Yeah, Oumuamua, which means a scout in the Hawaiian language. And that one was just found. It was flagged because it came near Earth. And this survey telescope was trying to find near-Earth objects that pose a threat, because Congress tasked NASA to find 90% of all objects bigger than a football field. And this survey telescope was constructed to find near-Earth objects. Then it found Oumuamua, but realized that it's moving too fast to be bound by gravity to the sun. And so that's how interstellar objects are flagged. You see an object moving too fast to be bound by gravity to the sun, and therefore it must have arrived from outside the solar system. So they discovered it by complete coincidence. Then a couple of years later, I found, together with my student, Amir Siraj, we found a meteor. In other words, an object that collided with Earth, 0.5 meter in size, in a catalog of fireballs that, again, NASA compiled based on US government satellites that monitor the Earth all the time for nuclear ballistic missiles. Obviously, we know that a lot of ballistic missiles were launched from Iran, last year. And so there is a network of infrared sensors looking at the Earth for flashes of heat.
Satellites and stuff.
Yeah, satellites. And those existed back in 2014. And they noticed a fireball from an object colliding with Earth. So that was definitely should not be classified. So they released it to the scientific community and said, here is a meteor, and documented the speed by which it was moving. And all we did was look at that speed and realize, well, it was moving at 60 kilometers per second relative to the sun outside the solar system. If we go back in time, this object was moving as fast as 3I Atlas. And so we said it's an interstellar meteor. That's it. And then the paper was not accepted for publication because the referee, the reviewer, said, we don't believe the US government data. So at the time I was...
Who said they don't believe the US government data?
The reviewer of the paper. In an
So
astrophysics journal.
someone sitting in a university somewhere?
Yeah,
Okay.
exactly. You have to understand the government is very believable because they discovered flashes of gamma rays back in the late 1960s with Vela satellites that were aimed to monitor any nuclear explosions above the atmosphere. Back then, there was an agreement with Russia, with the Soviet Union, but the US wanted to verify that the Soviets are actually not exploding anything.
Right.
And then they looked for gamma ray flashes and found every day or so there is a flash. So I'm sure in the first few days there was an alarm in Washington, D.C. But then they realized it comes from the rest of the universe. And so it was declassified and eventually reported. These are gamma ray bursts. Turns out they come from the edge of the universe, from massive stars that collapse to make black holes. And then the black holes, as the matter is funneled towards the black holes, you get jets being produced of outflows. So the matter forms a disk of material that spirals just like water going down the drain.
Mm-hmm.
And in the process of doing that, some of the material ends up being collimated in two jets that are perpendicular to the
black
disk.
hole?
The disk of material around.
This is what you see around the black hole.
You see that for big black holes, but in this case, the same phenomenon occurs for small black holes, stellar mass black holes. When the core of a star collapses, you end up with the material spiraling in and creating those jets. And those jets eventually drill a hole in the envelope of the star that originally lost its support. And they drill a hole and eventually they come out. And if we happen to be aligned, our line of sight with one of these jets, we see a gamma ray flash. Can you believe it? This is a flag of the birth of a black hole that we see, those gamma ray flashes that the US government discovered because they were monitoring the Soviets. And so there is this history of the US government helping fundamental science by discovering something that astronomers did not anticipate. And it took decades for astronomers to figure out the nature of these things because originally astronomers said, it must be relatively local because you need a huge amount of energy to produce these gamma ray bursts. And so they said it must be in our galaxy. But then there was an X-ray observatory that discovered X-rays coming from, afterglows coming from these gamma ray bursts. And that was an Italian satellite, Beppo-Sachs, and not a NASA mission because the NASA mission didn't put an X-ray detector on their gamma ray observatory. And so we realized that there are galaxies in those locations from localizing the X-rays. The gamma rays are difficult to localize in the sky, but the X-rays were. And so we realized that they come from cosmological distances, from distant galaxies. And then there is also evidence for an exploding star after the gamma ray burst. You can see a supernova. So these are the long duration gamma ray bursts. There are also short duration ones that are associated with the merger of two neutron stars. Neutron stars are the size of a city, the mass of the sun, and when they collide, they also produce these jets, and you see that as short gamma ray bursts.
Neutron stars are the size of the city and the mass of the sun.
About 12 kilometers in diameter, in radius, sorry. In diameter, about 24 kilometers. And they have roughly the mass of, even more than the sun, typically 1.4 times the mass of the sun.
Whoa.
These are the most dense remnants from the evolution of stars. What happens is a massive star that is more than 8 times the mass of the sun eventually collapses. It consumes its nuclear fuel, and after some time that ranges between a few million years to a few billion years, it ends up collapsing. Mm-hmm. And under some circumstances, it make a very dense core, which has nuclear density, just like an atomic nucleus, but the mass of the sun. Just think about it. That's a neutron star. It's made mostly of neutrons. And if it has more mass, eventually, a neutron star cannot have more than 3 times the mass of the sun. You can show that if it acquires more than that, it will collapse to a black hole. So above 3 times the mass of the sun, when you collapse matter, it ends up making a black hole, and then you get these gamma ray bursts, long duration gamma ray bursts. But when you make a neutron star, if you happen to make it, and there is another star that did the same, and you have a pair of these neutron stars in an orbit, you can get short duration gamma ray bursts from the merger. And by the way, we see also those events of mergers in gravitational waves now, the ripples of space-time from the edge of the universe. So we've seen black holes coming together or neutron stars coming together in addition to seeing them as gamma ray flashes. We also see them in gravitational waves, which is amazing because that's a prediction for Einstein's gravity. And, the discovery was in 2015, a decade ago, of gravitational waves. And so anyway, coming back to my story, the government definitely helps fundamental science. No way. I mean, when they detect something, they put so much money. The defense budget is $1 trillion in 2026. So you can't just say, oh, the government doesn't, you can't trust what they do with this. So my point is, when they say that this is the speed of the object, I believed it, but the reviewer dismissed it because the reviewer doesn't want us to move into this territory based on government data. So then I chaired the board on physics and astronomy of the National Academies, and I was complaining about it at a dinner that we had. That was around 2019, and one of the board members was in Los Alamos, and he offered to help me. And we reached out through the White House to the U.S. Space Command, and they took 2 years to issue a formal letter to NASA in 2021, in which they state that they looked back at the data and confirmed that this meteor indeed had an interstellar origin. Indeed, it was moving very fast. So the data is correct at the 99.999% confidence. It came from outside the solar system. You would think that my life would be easier after that. But what happened was that the paper got accepted for publication at last because of this. But I decided at the time to lead an expedition to the Pacific Ocean to search for the materials from this object. And when we went there, and this would be in the Netflix documentary, by the way.
This is the interstellar object that hit Earth, that impacted Earth.
That was the first one from 2014.
Right.
So when we went there, collected materials, at the same time, there were papers coming out saying, we don't believe the US government, this should be discarded. This evidence should be... We were coming with materials. So instead of those scientists saying, let's be curious, let's see what materials they found, like maybe there is something to this, No, there was a paper published in the Astrophysical Journal saying we shouldn't believe what this expedition is aiming to find. We shouldn't believe that this was an interstellar meteor. These are the forces acting in academia that suppress innovation, thinking outside the box. And by the way, it's not so much outside the box. We have meteors all the time, and we have interstellar objects that we know exist. So it doesn't take too much imagination to say some of these interstellar objects will collide with Earth. Right. What is the big problem here? Right. And why would you insist that the government doesn't know what they're doing if they report about meteors? So anyway, this is just a story to let you know. So there was, the first object was actually 2014, but the scientists, the comet experts are refusing to accept it.
So did you go and find it?
Yeah, we found materials. The method we used to retrieve the materials could just collect tiny droplets, molten droplets from the explosion.
Where exactly did it end up?
About 100 outside the territorial waters of Papua New Guinea.
Way out in the Pacific.
Yeah.
Okay.
So we went there. The ocean depth is about a mile at that location, and we used the sled covered with magnets that we put on the ocean floor, and we went back and forth to collect materials. And then we analyzed them with. I brought the materials to my colleague at Harvard, Stein Jacobson, who is a world-renowned geochemist, and he analyzed it for the past 2 years, and we found within the material some fraction of those molten droplets that have composition different.
Is that what it looks like right there?
Yeah, these are the molten droplets that we found, and this is an image of me on the deck of the ship that was called Silver Star, very fitting name. You see, these are beautiful. Wow. My wife asked, my daughter asked me after she, because I wrote a diary report every day on Medium, and millions of people around the world were monitoring that. And my daughter asked if I can thread these beautiful spirals on a necklace. Yeah, and I told her these are made of iron mostly, and they're tiny. They're less than a millimeter in size, so I cannot thread them.
You wouldn't be able to see them.
Yeah. So altogether, we found about 850 of them, which is a record. If you look at the literature prior to that, ocean expeditions found an order of magnitude less, or sometimes 2 orders of magnitude less. So anyway, these were analyzed, and we found a small fraction of them, 10% or so, had a composition that is different from solar system materials. But we want to go again and find bigger pieces because we cannot tell the origin of this object.
So who else has analyzed material that is not from our solar system?
Nobody.
And they think this is stupid.
Well, they argue that they don't believe the US government.
They argue that it's not from outside the solar system?
Yeah, they say maybe. So just to give you an example, there were a number of papers by critics. One said maybe it's coal ash. Just, human-made coal, burnt wood, for example. So in response to that, we analyzed the chemical composition of coal ash with, some tens of elements, from the periodic table, and also that of those special spherules that were enhanced in beryllium, lanthanum, uranium, kind of elements that were up to 1,000 times more than solar system materials. And we showed that it's not the same. So then another person said, okay, well, maybe it's some material from, the impact sites of meteors. It's called tektites.
Yes.
And we went to analyze tektites, and again compared and showed that it's not the same. So it takes a lot of work to demonstrate that all these debunkers are not making a good case. So we did the hard work. They had an easy time because they just sit on their chair and just refute and say, no, we don't believe it.
None of them came to look at take a look and analyze it themselves.
Well, the materials are in the laboratory of Stein Jacobson, and he did a fantastic job, and he has very good credentials. You can go to his lab and see what he did. I mean, we reported in peer-reviewed journals, we reported all the results. But the intellectual climate right now in academia is such that any new knowledge is resisted by experts. And the way I think of this is, you can understand it because we know about AI systems, right? We give them a training data set, and whatever they say is as good as the training data set. So imagine taking an AI system and training it only on asteroids and comets from the solar system, which is pretty much what these experts are, then they would argue that everything in the sky is a comet or an asteroid from the solar system. Mm-hmm. And my point is simple. It's definitely not the case because we know that we launched equipment to space. So, for example, on January 2nd this year, there was the Minor Planet Center, which is the official organization for cataloging objects close to Earth, announced a near-Earth asteroid. And then a day later, they realized, oh, wait a minute, this one moves along the path of the Tesla Roadster car that was launched by SpaceX in 2018. That was a dummy payload on the Falcon Heavy. So then they said, sorry, we take it out of the catalog because it's not a rock, it's actually a car. Now, the only reason there is a dozen of such cases in recent years. And the only reason they know about the fact that it's a car, it's just a source of light. It reflects sunlight, right? The only way they know is because they know what we launched. Now imagine that Elon Musk is not the most accomplished space entrepreneur since the Big Bang. Because, we existed, the human species had technological abilities only over the past century. And if another civilization existed, much earlier than us, because most stars from billions of years before the sun is a late comer. It just formed in the last 1/3 of cosmic history. So I can imagine there were far more accomplished space entrepreneurs than Elon Musk. And then there are cars in interstellar space, but not just cars. There could be equipment that is still functional, that can do things. And if you don't include it in your training data set, you would never consider the possibility that something that looks anomalous is really technological.
This episode is brought to you by Prize Picks. It's holiday season. Best time of the year for sports. Bowl games, basketball matchups, and NFL playoff pushes. And while you may be wondering what gifts to buy, what food to eat, or what games to watch, there is only one place where it feels good to be right. Prize Picks. I've used all the other apps before, but with Prize Picks, I understand why people use this app. You just pick more or less on your player projections. You throw a couple of picks into your lineup, and you're good to go. That's it. Daily fantasy without the chaos. This season, I'm looking at Brock Purdy. Can he hit more than 250 passing yards in that Christmas Day matchup? Christian McCaffrey, more than one touchdown in a game that actually matters for a playoff seeding? Nikola Jokic, can he put up more than 27.5 points in those big holiday NBA games? You scroll through, you make your lineup in less than a minute, and suddenly Sunday feels twice as exciting. And one more thing I love, if a player gets hurt early and doesn't return, you're not just dead in the water. Prize Picks has a really cool injury reboot, and deposits and withdrawals are super smooth. Venmo, Apple Pay, MasterCard, whatever you use, it just works. No waiting, no wondering, no calling your bank. So if you're like me and you live for those what if I'm right moments during a football game, then Prize Picks is the way to do it. Download the Prize Picks app today and use the code DANNY to get $50 in lineups after you play your first $5 lineup. That's code DANNY to get $50 in lineups after you play your first $5 lineup. Prize Picks. It's good to be right.
So Oumuamua, for example, was pushed away from the sun by some mysterious force. There was no evaporation of gas or dust from it. It was not the rocket effect that we're used to in comets. So what did the mainstream do, the comet experts do? They, most recently, I'm not talking back then. Back then, they argued maybe it's a hydrogen iceberg, maybe it's a nitrogen iceberg, maybe all kinds of, like a dust bunny, all kinds of suggestions. This is the mainstream, to remind you. Dust bunny, just a cloud of dust that is 100 times less dense than air being pushed by reflecting sunlight. That was one of the serious attempts to explain the anomalies. And then they say, no, that we debunked a non-natural origin by proposing these alternatives that were never demonstrated. It's just like you come up with a story and, why would it be a dust bunny? Why would it be a nitrogen iceberg? We've never seen that there isn't enough solid nitrogen in the Milky Way galaxy to provide a large enough population of such icebergs. And hydrogen icebergs, we don't know if they're even made in nature. We've never seen those in molecular clouds or anywhere. Anyway, the point is that Oumuamua had this feature, and non-gravitational acceleration, there was this force acting on it without any cometary evaporation, no gas or dust, even though the Spitzer Space Telescope looked for gas and dust, didn't find any. So then, right now, the comet experts are saying it's a dark comet. What does it mean? it means that they define it as a comet for which you don't see the signature of a comet. So it's an oxymoron. So suppose you're an expert on zebras and you go to the zoo, okay? And then you see an elephant.
It's a big fat gray zebra.
Yeah, you would say it's a zebra without stripes.
Right.
But it's still a zebra in your vocabulary, because your vocabulary is very limited.
Right.
So my point is, they would define spacecraft as dark comets because they don't see a cometary tail. Or, a spacecraft could even have some exhaust gas coming, out of it. And then they would say, oh, it's definitely a comet. There would be a press conference by an NASA scientist. We see gas coming out of it. It's definitely a comet. But you have to understand, their assertions are coming from when they say the 3I Atlas behaves like a comet. What they're basically saying is that there is a plume of gas around it. And by the way, only 4% by mass is water. So even though the experts were saying initially it must be water-rich, it's not water-rich. And also it responds to gravity, okay? But any object would respond to... so when these people say it walks like a comet, it talks like a comet, it's a comet, we should ask them, what about the anomalies? First of all, the big size of 3I Atlas. So it's so massive. How do you deliver such a massive object over a period of 1 decade? The second anomaly is the plane of the planets. How do you deliver it like a reconnaissance mission into that plane? By a natural process, because you should have monitored 100 objects before you saw one of them being aligned as much as 5 degrees with the ecliptic plane. Anomaly number 2. Then when you look at this object, even now, there seemed to be an extension of the object in the direction of the sun. So this is an anti-tail.
The anti-tail, yeah.
Anti-tail. So it's just like finding a street cat. Everyone says it's a street cat in your backyard, and I'm just saying, look, the tail is coming from its forehead, not from its back.
So we've never observed any kind of comet with an anti-tail. This is the first time we've ever seen it.
So when people say, oh, we have seen examples, they have to realize most of those examples were just optical illusion. In other words, we were positioned at an angle that looked as if the tail that is actually heading away from the sun is pointing at the sun just because of the orientation. It's a perspective effect. So we were looking at it from an angle that looked as if there is an extension towards the sun, but no. I mean, the reason, the physics of that is simple. The physics is that the solar wind and the solar radiation are pushing gas particles, dust particles away from the sun. Okay, so usually the sun-facing side is, losing those particles because it's heated, and then they immediately get turned around into a beautiful tail of either, gas particles like ions or atoms, or dust particles pushed away. But in this case, at least in the early days, of July and August, we saw an extension just towards the direction of motion, towards the sun. And it was really paradoxical. Now, the high-rise image in the NASA press conference, is really of very poor quality.
This is the one that you were talking about when you were on Rogan's podcast. The government was shut down and they wouldn't release the photos.
Exactly.
And they've now released them.
So this is a photo.
This is from the Mars Reconnaissance Orbiter.
Exactly. And there was a camera there called High-Rise. And it captured the highest resolution image of 3I Atlas with a pixel resolution of 30 kilometers when 3I Atlas came within 30 million kilometers from Mars. Okay? So it was a 0.5 meter aperture that was big enough to resolve 30 kilometers on 3I Atlas. However, because the camera was not designed to look at a moving object, it was designed to survey the surface of Mars.
Right.
The people who analyzed the data stated that there was some jitter in the camera that degraded the image, and they gave us.
Can you find this, Steve?
They gave us.
Where will we find this photo?
High-rise camera of.
Is it on your Medium account?
It's also on my Medium, yes. But you can just put.
Just go to Avi Loeb's Medium account, bro. You'll see it.
Or you put a high-rise image of 3I Atlas, and the point is that if you look at that fuzzy image, which by the way is much worse quality than the amateur astronomers' images
really
now, yeah. what you see is an extension of the glow around 3 Atlas in the direction of motion, not in the direction of the sun. Here is the image. You see the direction of motion is roughly perpendicular to the direction of the sun for the first time, because previous images were taken when this object was approaching us and the sun. We were just separated by maybe 10 degrees from the direction of the sun. So we saw the object approaching us. But when it came close to Mars, the high-rise camera could look at it from the side, okay, and could see it when it was moving roughly perpendicular to the direction of the sun. Okay, so you see the two directions.
So this is the photo from the Mars orbiter right here.
Yes, exactly. And
it's so if the orbiter is on the surface of Mars or on the edge
just
of Mars,
hovering above, yeah.
Which direction is the comet moving?
So it's moving sideways relative to the direction of the sun, as you can see here.
I see.
Because it was basically passing near Mars on a line that was getting closer and closer to the sun. But when you look at it from Mars, the vantage point of Mars...
Is it traveling away from Mars? Or is it traveling perpendicular?
It's traveling here. This is the orbit, you can see. So you see 3A Atlas is passing, it's passing very close to Mars, which is one of the strange qualities of this trajectory, that it comes very close to Mars.
Nowhere near Earth.
No, Earth is actually on the opposite side of the sun when it came closest to the sun, which suggested maybe it's avoiding us because it will use the opportunity of coming close to the sun as to gain something from, to get gravitational assist if it releases some probes, for example, or does a maneuver. But when it came closest to Mars, it was moving in a direction that was perpendicular to the direction of the sun. And then we see the glow extending in the direction of motion ahead of the object. Again, never seen before.
Really?
Yeah, because usually you expect the direction of the sun to dictate where you get the evaporation, right? So the sun-facing side gets evaporated by the sunlight, and then the material gets pushed back by the solar radiation pressure and the solar wind. But so it gives preference to the object-sun axis. However, here we see the plume extending ahead of the object. It's not a trail behind the object that is left behind. It's actually ahead of the object. So the question arises, is it a beam of light or a beam of particles used by a spacecraft to clear out any micrometeorites or impactors that can damage a technological object? That could be one possibility. But in the NASA press conference, no discussion of that anomaly.
What are these conservative, conventional astrophysicists saying about the anti-tail? Like, what is the most compelling pushback that you've heard about the anti-tail?
Yeah, so in the original report about the Hubble Space Telescope image from the 21st of July, there was the interpretation that perhaps, usually dust particles that have roughly the size equal to the wavelength of sunlight, which is about half a micrometer, half a micron. Those particles, dust particles, scatter sunlight most effectively because they have a lot of surface area. And bigger particles do not scatter sunlight as effectively. Again, big things have less surface per unit mass. So usually the story is that submicron particles scatter sunlight, and then you can calculate, if they scatter sunlight, they also get pushed behind the object. They create a tail. There is no escape from that because the same process that gives you the glow from scattered sunlight also pushes them. So the suggestion was maybe we're dealing with dust particles that are much more massive, 1 million times more massive. So they have a size of 100 micrometers or more. So they're so massive that they have much less surface per unit mass. So they get pushed very little by the sunlight. But that would mean that you need to release much more mass in those particles to end up with the same glow of light. At any event, that is the more conventional interpretation, to say the dust that is ejected by 3A Atlas is much bigger, 100 times bigger particles or 1 million times more massive particles, and because of that, they don't turn around and get pushed back. Now, I wrote 2 papers with a colleague, Eric Kito, and one of them was just published after peer review, where we said maybe these are ice particles, just ice that eventually gets evaporated before it has a chance to turn around. It's not dust particles that survive sunlight. It's actually ice particles that get evaporated and then...
So it's like the side that's facing the sun.
Right.
It's boiling the front of it and making a little plume.
Plume of icy particles.
Yeah.
That was a conventional interpretation. But the thing is that our paper and the original paper are the only discussions on this issue. So when people say it's a comet, they don't attempt to explain the anomalies I mentioned. They just ignore them. Okay? And that's what you should ask NASA officials when they say we are confident it's a comet. Okay, how do you explain the large mass of the object? How do you quantitatively, not just say, oh, comets are weird and some of them are unusual and therefore it's okay.
They're all different, right?
But that's not an explanation if you don't have enough mass in rocky material in interstellar space to accommodate the delivery of such a package over the past decade. You need to explain that. You can't just ignore it. This is not politics. We are talking about science here.
Right.
And you have to think. You can't just... So you can't just be a bureaucrat that makes statements and everyone should believe you because of your authority. That's not the way science is done. We all know that the Church, the Vatican, apologized and admitted 350 years after Galileo died that he was right. Mm-hmm. That was a very bad public relations stunt. Imagine NASA coming up and saying it's definitely a comet and something ends up being a technological relic. How would they look? Right. So if you want to be sincere and honest, you don't make some authoritative statements by bureaucrats. Mm-hmm. You go to the data and explain the anomalies. So if you want to say this is definitely something we understand, you have to explain why is there a glow ahead of the object in the direction of motion according to the image that you are showing in the same press conference.
Right.
I'm not saying about other images. Even your image is paradoxical.
And explain it to people. Explain it to normal everyday people that can't understand physics or can't or don't have a deep understanding of astrophysics. We are human beings that live on the earth. Why can't we understand this?
Exactly. No, so that's exactly my point. People ask me, why are you putting a significant fraction of your time explaining to the public? And I say it's because, I'm puzzled just like the public. I don't feel myself different than the public. I just have the privilege of using the scientific method to answer questions that I'm curious about. And I take, I'm very respectful of the curiosity of the public. So when the public tells me the most interesting question for us is, are we alone? Is there, not in the sense of microbes, but is there another intelligence out there? I take it seriously because the public funds science by paying taxes. And
right.
What the mainstream community is doing is saying, thank you very much for the money. We decided to use $10 billion over the next 2 decades to look for microbes because we think that we are more likely to find evidence for those than technological signatures. They decided that. The gatekeepers said, give us the money, and that's what we will do with it. And I say, no, we should hedge our bets. We should listen to the public, and we should put billions of dollars to the search for intelligent life in the universe, technological signature, as much as we put towards the search for microbes. This is just a matter of common sense. Anyone that bets, in the stock market or anywhere else would argue that you need to diversify your portfolio. You can't just be obsessed with microbes and say, we will put $10 billion to that, to the search for microbes, and zero out any investment of federal funds in the search for technological signature, which is exactly the reality that we live in right now. I'm not inventing this. This is the intellectual reality within academia right now. Let's focus on microbes. It's completely legitimate. If I were to write a paper about microbes, it will be embraced. Nobody would. If I were to do it, of course, 2 decades ago, then there would be attacked. When I started doing astrophysics, people didn't believe that there are exoplanets. So I've been around, I've been around for 50 years, half of the modern history of physics. I know how trends are becoming popular when before they became popular, they were ridiculed. I see that again and again in many different contexts, including the discovery of exoplanets. And the story there is that there was an astronomer named Otto Struve who in 1952 said, we can search for a Jupiter-mass planet close to a sun-like star by the fact that it blocks part of the light of the star when it moves around it, if we are oriented in the right way, or because it jiggles the star back and forth. And it was doable. But then for 53 years, people didn't follow on that because they said, we know why Jupiter is so far from the sun. It's because that's where water ice forms, and we have a theory for that. We will not waste telescope time in looking for Jupiters close to a sun-like star. So then in 1995, there was a discovery of a hot Jupiter, and the Nobel Prize was awarded for that discovery. And if you look at the paper, the discovery paper of the hot Jupiter, you don't see a reference at all to Otto Struve's paper that suggested using the same technique.
Wow.
And so what does it show? It shows that science is not efficient because prejudice suppresses innovation. Why would innovation be embraced by the high-tech companies? Because they realize that, even if you invest in 100 ideas and most of them are wrong, if one of them turns out to be right, you can make a fortune. So So in the financial sector, where you might say people should be most conservative because it's their money, they realize the value of taking bets and, hedging our bets and doing risky projects. In academia, no. And that is surprising. Why? Because the whole idea of tenure in academia was meant to give a sense of job security that will allow you to innovate without worrying that you would lose your job. And what happens in reality is that members of academia are becoming very conservative as they get tenure because they have their own echo chamber. They educate students and postdocs to repeat their mantras. Basically, it's an echo chamber, and the students and postdocs realize that to get jobs, they have to repeat what was said already, instead of encouraging them to break out. Mm-hmm. So you end up with a situation, just to get honors, awards, support, financial support for research, you have to dance by the tunes of selection committees that are emphasizing past knowledge. They don't encourage those people who are pioneering new knowledge.
Right.
And that's the reality that I face.
Yeah. It's did you ever expect to get this much pushback or take this many arrows from coming out and speaking about this stuff as much as you are?
No, because I started in studies of the universe, cosmology, and we should admit that we know very little because Nobel Prizes were awarded to people who quantified how much we don't know. Mm-hmm. We know that there is most of the matter in the universe, is invisible. We don't know the substance that makes most of the matter in the universe. It's called dark matter.
Right.
And we're talking about of all the 85% of the matter is of an unknown substance. And, that's quite remarkable. And in fact, it took, again, 40 years for the community to even recognize that after Fritz Zwicky suggested the name. He talked about invisible matter that he discovered just based on the gravitational influence of this matter on visible matter. So we know there is much more matter out there, but we don't know what it is. And then there is most of the energy in the universe also. It's called dark energy. So, I came from that field. And when I wrote more than 1,000 scientific papers and wrote about 8 books. When I worked on puzzles, or you can call it anomalies, in cosmology, like the dark matter, it was very much encouraged. If you come up with an idea that is non-conventional, that explains dark matter, everyone said, great, now we can actually test it. And they would be encouraged to either do experiments or suggest theoretical arguments that prove you wrong, but it was a very collegial environment, intellectual environment. Then I get to this, so I continue to practice exactly the same principles of suggesting something new so people would appreciate it and, try to either rule it out or rule it in, and that's a fair game.
Yeah.
And I get to this subject where you have people who work on rocks in space. And, it's a very different intellectual climate. I would make the distinction between playing chess Studying the universe, cosmology is just like playing chess. You have to think about the moves and what's the right thing to do. Whereas in the case of rocks, it's more like mud wrestling, where people are not intellectually driven. They just will bring you down because you said something different, and they are the experts.
Yeah. Yeah. Well, it's unfortunate the amount of ego and gatekeeping and just bias that's built into academia from, the money and the competition for grants and
Right.
all that kind of stuff, when there should be more curiosity.
Exactly. So here is my definition of science, and that's the way I understand science after practicing it for 50 years. Science, the foundation of science, is the humility to learn. You have to be humble to admit that you don't know the answer in advance. Mm-hmm. So the foundation of science is the humility to learn, not the arrogance of expertise. And what you see in academia is the arrogance of expertise, where people say, I know what it is because I'm the expert. You don't have a track record of 30 years working on the subject, therefore you have nothing to say.
Right. And this is not only in astrophysics, this is in every aspect of academia, every channel of academia, and every single profession, every industry. It's ubiquitous, unfortunately.
Yeah,
and it's part of human nature.
I visited Denmark, Copenhagen, at the end of August. There was a conference in the Niels Bohr Institute there. And I entered the auditorium of the conference, and it looked familiar. Why? Because it appeared in a photograph from 95 years ago, where the founders of quantum mechanics gathered in the same auditorium. So there were all these famous people like Niels Bohr, Max Planck, Werner Heisenberg, Wolfgang Pauli, Lev Landau. So I recognized the place, and I went to sit on one of the benches, and someone said, "Oh, you're just sitting where Wolfgang Pauli sat at that conference." And all I could think about is how uncomfortable is the bench. It's made of wood. And, people back then had very low quality of life. Just think about sitting on this wooden bench. It's so uncomfortable. But I would trade everything I have, going back 95 years, to the time when the pioneers of quantum mechanics were open-minded. They revised the way we think about the physical reality. That was dramatic. Even Albert Einstein couldn't believe it. He tried to argue that no, there cannot be spooky action at a distance, quantum mechanics. But Niels Bohr said, no, you have to embrace the new understanding which makes the physical reality very different than what you're used to. He said that to Einstein. Einstein didn't accept it and was wrong. Niels Bohr was right. Mm-hmm. And the point is, quantum mechanics is now the foundation for all the technologies we use. The way we speak right now with a microphone, everything is based on electronics, with the foundation of quantum mechanics. 95 years ago, that's when they discovered the fundamental principles that allow us to build these technologies. And it was all based on curiosity and the humility to learn. That was exactly the argument of Niels Bohr because Einstein was respecting past knowledge, classical physics. He wanted to understand quantum mechanics in the same way that classical physics is understood. Mm-hmm. But Niels Bohr said, no, it's a new reality. And that's the humility to learn. And that's why I would go back 95 years, sit on this wooden bench for as much as you ask me to sit, being surrounded by innovative minds where, attempts to understand nature are not ridiculed. And what you find instead is in fundamental theoretical physics for 50 years, the prevailing paradigm was there are extra dimensions, string theory will unify quantum mechanics and gravity, and we haven't seen a single piece of evidence to support that speculation, that there are extra dimensions. In fact, supersymmetry, which was at the foundation of string theory, was not found by the Large Hadron Collider that cost $10 billion. So you see a mainstream in theoretical physics for 50 years working in a direction that did not produce any fruits. It doesn't make a prediction, doesn't explain why the Big Bang happened, what happens inside the black hole, doesn't resolve any of the anomalies. that we are aware of in the universe, but nevertheless, this is very popular. Now, I don't see any of these critics saying, oh, what is wrong with those people? They have a speculation about extra dimensions. We don't see them. That's a much bigger speculation than arguing that a meteor that the US government reported about was interstellar, or arguing that 3I Atlas might be technological. Why? Because we know of such objects that collided with Earth probably from interstellar space, because we know about interstellar objects. And we know about technological objects in space because we launched them. So my point is, what the resistance you find from the critics is disingenuous. It's not sincere, because they should have criticized the community who speculates much more, which is the mainstream of theoretical physics. Why don't they do that? Because there is a large community out there, and all these science popularizers like Brian Cox or Neil deGrasse Tyson will never raise a doubt and go against them, because then they would lose popularity.
Right. Well, they're certainly not taking a risk, right? You're certainly taking a risk by going out on a limb.
Yeah, but why isn't that a risky proposition to imagine extra dimensions?
I agree with you. I completely agree with you there. But it's just like, it makes sense why these people don't want to attach themselves to or agree with your speculation, because you're already out on a thin limb trying to propose the idea that this could be some sort of technological object from another star system. And if they sort of march out onto that branch with you, and then for some reason you get proven wrong or whatever, they don't want to be associated with that and have a stain on that.
So what you're saying is that string theory, since it has no experimental test, will never be proven wrong, and therefore it's a safe bet to continue to advocate for it?
Right. No, I agree. The contradiction is insane.
I mean, this is the way science is done. You have to put hypothesis forward. And sometimes you're wrong, sometimes you're right. Albert Einstein was wrong 3 times between 1935 and 1940. He argued that quantum mechanics doesn't have spooky action at a distance, as we just said. He argued that gravitational waves do not exist and black holes do not exist. And this was when he arrived at Princeton, the Institute for Advanced Study. So he was at the prime of his career, made 3 mistakes, and the experimental teams that proved him wrong got the Nobel Prize over the past decade. And my point is, if you're working at the frontiers, you have to be bold, take some risks, and you might be wrong. But one way or another, you advance our knowledge. And just resisting a possibility because we don't like it, because it doesn't represent our past training data set, is not a good enough argument. Because then you should argue that string theory should not be pursued. What evidence do we have for that? At least for space objects, we have evidence.
Do you think that there could be some sort of group or shadowy organization that has been responsible for siloing certain discoveries in science or physics research in the past or currently? Like, for example, trying to throw the trajectory of mainstream research off a certain path and trying to take certain discoveries or certain areas of research, take it black into the military sector or whatever, so the public can't get its hands on it.
Well, that would be a viable hypothesis if the government has information that we don't know about. Okay.
Like, for example, if you made some crazy discovery, right, and you were talking about it with your colleagues, and then someone from some intelligence organization came to you and was talking to you and saying, hey, for national security, we can't make this public. You need to come work for us now. Something along those lines.
Well, they cannot do that because science is done by many people, and eventually the data will show it. So that's the lesson to learn from Galileo Galilei telling the church, I see moons around Jupiter, therefore the Earth is not at the center. By suppressing Galileo, they just benefited for a short while. But eventually there were so many observers that, in fact, we have spacecraft that look at the Earth from a distance and show that the Earth moves around the sun. So the point is, you can gain some time during which you spread misinformation, but in the long term, it will be found. So there is no point.
Sure.
So dealing with things outside the solar system is my day job.
Right.
The government's day job is national security. Okay? The two are completely unrelated.
Sure.
So if they have information, let's say from 50 years ago, that indicates superhuman intelligence, there is no excuse for them to keep it confidential, because any technology developed by the Russians or others, adversarial nations, is irrelevant today. If it was 50 years ago, it's irrelevant today. And so if they had something that they retrieved, they cannot understand, just show it to scientists like myself and let's figure it out.
Right.
Because it's not relevant anymore. That's before the space age. I'm talking about if they have something like that.
Yeah.
So my point is, if they ever want me to sign an NDA, it will be about information that is relevant to national security. It shouldn't be about what lies outside the solar system.
The reason I ask is that there's overwhelming evidence that the government has done this in the past, right? I mean, just to talk about the UFO topic for 1 minute, there's an absorbent amount of evidence of people that have come out, whistleblowers, books written, papers written, and interviews done with folks that have been around, like, for example, the Roswell crash in 47.
No,
and attested to the government having this sort of technology that's unexplainable if it was created on Earth. These like flying saucers or flying discs or whatever they are.
That's exactly why I'm leading the Galileo project, and we are constructing observatories. The most recent one was in Nevada, and we are monitoring the sky 24/7, the entire sky, with multiple units to triangulate on objects and figure out their distance, velocity, acceleration, check whether they are performing outside the envelope of human-made technologies. So I'm pursuing the scientific path because, it will take us forever to wait for the government to release their data. So I'm saying if these objects exist, we'll find them. Now, I've been, I was briefing Congress on the 1st of May this year, and the day before I went to visit the All Domain Anomaly Resolution Office in the Pentagon, and I asked them, do you see anything? Because they claim they looked at all the reports within government, they have access everywhere. And they said, so far, we haven't seen anything unusual except for some reports from FBI agents that do not have quantitative data. That's what they said in the Pentagon. Now, the day later, I hear Eric Davis, who just appeared in the Age of Disclosure, sitting next to me in Congress and saying, there are a dozen craft with pilots in them and so forth that the government has, and they gave it to corporations. And so
Half said the same thing.
Yeah, but then, I'm a scientist, okay? So I don't believe stories. People can tell me stories, I wouldn't believe it. For the same reason that FIFA, the Soccer World Organization, when there is a dispute on the soccer field, they don't go around and ask the players. They just look at what the cameras show.
Sure.
So within the Galileo project, we built cameras that can tell us. I don't care what this person said, it's intriguing. That's what inspired me to follow this path, but I want to see the evidence. Okay, so once I see the evidence, and by the way, I don't need to tell others. I just want to know. Okay, and that's my driver. And so, I once asked my class at Harvard. I said, if a spacecraft lands at Harvard Square, I asked the students, and you're offered a one-way trip, would you take it? And these young students, undergrads, they said, only if we have Wi-Fi connectivity so we can use Instagram to show our friends about, inform them about our experiences. And I said, why would you care about your friends if you're on a one-way trip out of Earth? So to me, it's just my knowledge. And I don't, if the government comes forward and shows something to me and they tell me not to disclose it, I want to know.
Would you agree to that?
I would agree to that, but at the moment nobody said that, so I don't know if there is anything. So the point of the matter is, until I see the evidence, I don't care about stories. They are not enough for me.
For the record, I think I would agree to that too.
Okay.
If they came to me and said they're going to tell me the truth about everything and they want to show me the flying saucers, I'd agree.
Exactly.
Never to say a word about it.
That's okay.
I think in a heartbeat I would do that.
Yeah. By the way, I should say that about the flying saucer. A decade ago, I asked my wife if she what does she have to say about it, and she said, "Well, you can go on this spacecraft, no problem.
Yeah.
But just make sure you leave the car keys with me, and ask them not to ruin the loan when they take off." And now I asked her again a decade later, and she said, "I will join you."
Oh yeah.
She's so disappointed by the daily news across the world
Uh-huh.
that she's also tempted to leave this earth.
Yeah, it's unfortunate. Are you familiar with John Mack?
Yes.
You seem to be on a very similar trajectory that John Mack was on.
No. Very different.
Not. Well, it's very similar. He was different. He was a psychologist, and he was interviewing people who claimed to have
So he
alien
was
abductions.
focusing on stories that people tell him. I'm shying away from stories that people tell me.
Right, but he was also doing it in a scientific manner.
No, that's okay.
He was doing
the method was scientific and therefore similar, but he was focusing on people. And I say, don't focus on people.
Right. Well, you can't take pictures of memories, right? I mean, he was interviewing hundreds of folks all over the world who had very similar experiences.
Yeah, but you have to understand that people know about each other or they know about stories. And in addition, there may be some psychological trends that are common to people. Like everyone would, have similar illusions because the way the brain works. So if you rely just on people, that's not enough.
So what is your take on that stuff?
My take is that it's intriguing, but not conclusive in any way. I never had an experience myself, and I've never seen direct evidence, but I'm curious enough from the storytelling, by witnesses and so on, curious enough to address this important question scientifically, because that's the only way by which I think we can convince everyone that it's real, if it's real. So I want to see the evidence. If it's not real, then I want to know that and just save time for all the people that think that it's real, like forget about it. It's just like... I remember when I was young, there were lots of young people who said, I want to meet my ideal partner, and that partner needs to look like a movie star, and it needs to be as smart as Einstein, and so forth. And then, at a late age, nobody showed up that fit those characteristics, and they had to compromise. Now, if you have if you imagine something exists in reality that doesn't really exist, you have to have a reality check. And the best reality check is to look for the hard evidence. That's what I'm doing. And maybe this, what we are talking about exists, and then I'll find it, and then, that will change our future dramatically. Because if we realize that there is a smarter kid on our block, there is a more accomplished sibling that we didn't know about, if we realize that there is room for improvement, that there is superhuman intelligence out there, then we will try to do better, And instead of engaging in conflicts, we might decide to cooperate on this rock. We are all in the same boat, all humans. So we would recognize the similarities that all members of the human species have, given that there is someone else out there who is different, especially if that someone may be a serial killer. If you realize that you're on a blind date and on the other side there is a serial killer, then you get your act together. So the threat from alien technology could bring people together because it will be shared by all humans on Earth. And you don't want, some members of the human species to rock the boat too much because it will endanger everyone.
What did you come up with the theory that it could be a Trojan horse? It could be a spaceship disguised as a comet?
No, well, many people suggested that it's a possibility, and that's why, but you can tell the difference because nowadays, with the Webb telescope, for example, you can look for a source of heat that does not just reflect the illumination by sunlight. Okay, so you might see a hot engine. In fact, 3A Atlas became bluer than the sun when it came close to the sun. And the question is why? Blue is usually associated with hot objects. It may be that some molecules emitted in the blue band, and that's what we saw. But at any event, it was a fact. By the way, most recently, just a few days ago, I realized another anomaly of 3A Atlas that I never thought about before. And that is, the path of 3A Atlas takes it closest to Jupiter on March 16th, 2026. And it's possible to forecast the distance that it will have from Jupiter on March 16th. Turns out that this distance, to within 4 significant digits, is exactly the distance from Jupiter where Jupiter's gravity wins over the sun's gravity. So the sun's gravity introduces a tidal effect. Basically, it rips apart any satellite of Jupiter that is beyond this distance, which is called the Hill radius.
The Hill radius.
Yeah, it was discovered by a physicist with that last name.
And this is around the entire circumference of Jupiter.
Well, it's around Jupiter, and out to that distance, if you put a satellite, it can remain bound to Jupiter. If you put it outside, it will be torn apart from Jupiter by the sun.
And why is that?
And by the way, this distance depends on time, because as Jupiter goes around the sun, the distance between Jupiter and the sun changes slightly. And so I calculated it on March 16th, and then you find within 4 significant digits, it's the same. Now,
within 4 significant digits, what do you mean by that?
I mean that it's the number that you get for the distance is identical to 4 digits. Now, there is some uncertainty in the forecast. The uncertainty puts it in agreement with the value that we know should be the Hill radius for Jupiter on that date. Now, the plot gets
so on
thicker.
March 16th, the 3i Atlas is going to be underneath that,
just exactly at that distance,
at the distance to where it will be able to be like in the orbit of Jupiter.
Yeah, so there are the so-called Lagrange points, if you're familiar with that. These are the points where if you put a satellite, you need very little maneuvering or fuel supply to keep it there, because there is almost zero gravity there. So the attraction to Jupiter is balanced by the gravity of the sun. And so the Lagrange points, L1 and L2, the 2 first Lagrange points, are exactly on the Hill radius, on the Hill sphere. But anyway, so turns out that there was some non-gravitational acceleration observed for 3i Atlas, meaning that when it came closest to the sun during the month of October, it deviated from the original path a little bit. And that level of deviation, I calculated, allows it to come exactly at the Hill radius. If it didn't have the non-gravitational acceleration, it would have been off. And so the question arises as to whether the non-gravitational acceleration resulted from some engine that gave it, provided it with adjustments to its trajectory, and did it close to the sun in order to get a gravitational assist from the sun, so that it gets exactly where it needs to get, so that it can deploy devices near Jupiter, maybe at the Lagrange points, or
deploy devices like probes or something.
Probes, yeah, or communication devices, or maybe collect something that was put there before. I mean, I have no idea, but it's just a coincidence that has a likelihood of 1 in 26,000, given how many significant digits are. We're talking about 54 million kilometers from Jupiter, and so if you just say, well, in principle, it could have been anywhere, because Jupiter moves around the sun. It has an orbital radius around the sun. So the passage of 3i Atlas could have been anywhere between a distance of 0 and a distance equal to the diameter of the orbit of Jupiter around the sun, and then you find a chance in 1 in 26,000 that it would have come that close to the Hill radius. You might say coincidences happen. I met my wife on a blind date. What's the chance? But this is 1 in 26,000 on top of the other anomalies that I mentioned before. Why would it get to the Hill radius exactly to 4 significant digits? Now, we will be able to tell when it gets there, because we have orbiters like the Juno spacecraft there that could monitor if anything unusual happens, if there are any satellites being deployed.
The Juno is going around Jupiter.
Yes,
and we can tap into the Juno and get the pictures from it.
Yeah, definitely. Juno will also has also a radio antenna that can look for radio signals from 3i Atlas if there are any.
And NASA controls all this.
Yeah, but I spoke to the principal investigator of Juno, and he's a faculty member at the university, and he told me that they will do the best they can. I was hoping they can bring it closer to 3i Atlas, and in fact, Representative Anna Paulina Luna wrote a letter after I spoke with her on the phone about the 3i Atlas, and so she very generously encouraged NASA to use Juno and look at the 3i Atlas, which I hope they will. But the point of the matter is, with more data, we can figure out if there is really something strange going on. If it was targeting Jupiter, not the Earth, by the way, it would feel as if we are in a party, but nobody wishes to dance with us. They all, so for some reason, that visitor does not care about us. It doesn't care about Earth, which could be for a good reason, because it started its journey 1 billion years ago. Jupiter is the biggest planet in our solar system, was visible from a distance, and they have some mission to accomplish there. Nothing to do with the Earth, and the Earth became interesting only much, much later. So I'm just saying it's an anomaly that should be looked at. What I want to, in the coming weeks, leading to December 19th, that's when 3i Atlas will come closest to Earth. So in the coming weeks, we'll have a flood of data coming from hundreds of observatories around the globe, because the International Asteroid Warning Network decided to coordinate observations of as many observatories as possible on Earth between November 27th and January 27th. So we will have a lot of data also from the space telescopes. And I want to figure out, there are multiple, in the amateur astronomers' images of 3i Atlas, there are multiple jets coming from 3i Atlas. In an early one, I counted 7 of them, 7 jets. And the fundamental question is, are these jets simply the sublimation of pockets of ice that are illuminated by sunlight? In which case, it will demonstrate that this is a natural object, a rock. Or are they produced by thrusters, technological thrusters, in which case the speed of the gas coming out of them should be much larger, because the sublimation of ice gives you at most a speed of 400 meters per second. That's the thermal speed of molecules at the surface temperature of 3i Atlas. And chemical thrusters like rockets, they operate at a few kilometers per second, a factor of 10 higher speed. And then you have ion thrusters that operate at tens of kilometers per second. That's a factor of 100 in speed. So if we measure the speed of the gas in those jets that are observed, we will be able to tell if it's natural or artificial in origin. These jets are... and I don't have a problem. I defined a scale between 0 and 10 back in July that is called the Loeb scale, where 0 means that it's a natural object for any interstellar object, and 10 means that it's technological and a potential threat to humanity. And I don't mind bringing it all the way to 0 if it becomes obvious that these jets are moving exactly at the thermal speed that we expect. The object is much smaller than I thought it is. It's basically smaller than a kilometer. And it happened by coincidence to be a rock on a path that goes through the plane of the planets around the sun. Fine.
Where are you at in that scale right now?
I was, to start with, at 4.
This was in July.
July, August. And right now, I'm asked by many people, but I'm waiting for the data, because it will be foolish of me to change my ranking when the data is just about to come forward. And so by the holidays, we should know. And let's just hope that we will not get any unwanted gifts for the holidays from this object.
So you're still currently at a 4. And today is, what's the date today? November what? 25th.
Yeah. I haven't revised it because I'm waiting for the future data, but I will bring it all the way down to 0 if it looks like all the properties of the jets appear to be natural. And on the other hand, if it turns out that it comes to the Hill radius of Jupiter for a good reason, because it does something there.
And that's in March, right?
March 16th.
Okay. I want to get more into these anomalies. I got to take a leak real quick.
Okay.
So we'll be right back, folks. Okay, we're back. So in a perfect world, if Avi Loeb was in charge of NASA, what would you do right now with 3i Atlas?
Oh, I would just encourage scientists to look at it. That's all. There are lots of facilities, space assets that can be used. And so science is guided by evidence. And so we should collect as much data as possible. This is an amazing opportunity. It's a gift because it's a big object that is very bright and it's passing through the plane of the planets around the sun where we have all the space assets to observe it. So it will, if it's a rock, it will not happen for a while that we get these coincidences. It's a gift that nature provided us with that is extremely rare.
How long is it going to, oh, sorry to interrupt. I was going to say, how long is it going to be in our solar system for?
It will pass Jupiter in March, and after that it will go farther away. So if it's technological, you should think of it as a mothership that left behind some probes or collected information that it will use. If it's natural, that's the natural outcome, given the fact that it's moving so fast. It was not deflected much by the gravity of the sun. If you look at Oumuamua, for example, it was moving much slower, at least by a factor of 2. And as a result, when it came close to the sun, the trajectory was deflected significantly. It looks almost like a U-turn that it made as a result of the sun's gravity. But in the case,
Oumuamua was not technological. You've confirmed.
No, we don't know.
Oh, you still don't know about that.
My explanation for the fact that it was pushed away from the sun.
Oh yeah, look at that! Look at that trajectory.
Yeah, so in fact the trajectory,
So
you
it
see the
comes
large
down
angle? The
and
large
it does
angle?
yeah, it does almost a U-turn,
Yeah.
like a V-turn.
A V-turn, right. And so...
So that's because it gets so close to the sun, it gets almost inside the orbit of the Earth and the sun,
yeah,
right?
it does come inside the
And then the gravitational force of the sun sends it on that V, that V trajectory.
Exactly. And look at the large angle at which it's coming into the plane of the planets.
Right.
And that should be typical. However, with 3I Atlas, it's coming within 5 degrees of that plane.
And what was Borisov's angle?
Also big.
Also like that?
Yeah, because that's what you expect. And that's what triggered my interest in 3I Atlas, the fact that it's so anomalous in its arrival direction.
Now, we can only see we've only started looking at these 8 years ago.
Right.
So we don't know
how they are distributed.
How many have been coming through in the past?
Oh, no, surely a lot. It's just that we are aware of them now.
Right.
And the point about 3I Atlas is that for every object as big as it is, there should be millions of objects like Oumuamua passing through the solar system.
So you think it's possible that there's, even though we still have all these telescopes looking out trying to find these interstellar objects, do you think it's still possible today that we are missing some?
Oh, definitely. The point is, if these are rocks, let's accept that NASA's view that they are just icy rocks. Okay?
Right.
In that case, for every object like Oumuamua that is, let's say, within the orbit of the Earth around the sun, there should be a quadrillion of them making their way through the solar system right now, because the solar system extends out to 100,000 times the Earth-Sun separation. That's the Oort cloud of, there are all kinds of Lego pieces left from the formation process of the planets in the sun, in the solar system, near the sun. So the sun formed out of a disk of material that fed it. Again, just like the black hole example I mentioned before, like water going down the drain, usually gas gets organized into a disk when it has rotation around the center, and that keeps it from falling straight to the center. So it goes around and spirals in and feeds the newly formed sun in the case of the sun, or a black hole in the core of a star, as we discussed before. So what happened was there was some leftover material, less than, of order a few percent of the mass of the sun left in a disk. And that ended up coagulating, starting from dust particles that form in the midplane, coagulating into planets, okay? And accreting material from the disk. So that's how the planets were formed around the sun. They all lie in a plane because they originated from gas that was organized in a plane. See, that was already recognized centuries ago,
right,
by Laplace and others. And so the point is that we can see some of the building blocks of the planets left from that formation process because they were scattered into the outskirts of the solar system. We see the Oort cloud, which are bodies that were scattered in roughly a spherical configuration around the sun, going out to 100,000 times the Earth-Sun separation. Wow. And that means the volume associated with the Oort cloud is 100,000 cubed. Okay, so because in each direction it's 100,000. So 100,000 cubed is 10 to the power 15 or a quadrillion. So for every object you see within the orbit of the Earth around the Sun, there should be 10 to the power 15, a quadrillion objects, right now making their way through the solar system from interstellar space of the same size. That's for random objects. And it also means that every star like the Sun, because the Oort cloud of the solar system is touching the Oort cloud of the nearest star. It's roughly halfway. It ends halfway to the nearest star. And you can think of these Oort clouds just like billiard balls that are densely packed. They are touching each other for an obvious reason, because if the Oort cloud were to extend farther than that, a passing star would rip it apart. Okay, so the extent of the Oort cloud is dictated by the characteristic distance between stars and also the tidal force from the Milky Way galaxy. At any event, so what it means is that that every star in the Milky Way galaxy must have produced a quadrillion objects during, the age of the Milky Way galaxy, and that's a large number.
How do we not get smoked by one of these interstellar objects?
Oh, because space is vast, and these are very small objects. So the chance of them, for example, colliding with Earth is very small. But most of the time, they are just passing through, and the Earth doesn't intercept them. The Earth, the cross-section of the Earth is small. And the same is true for all other bodies in the solar system. So if you ask, suppose I have a spacecraft that wants to travel to interstellar space, what's the chance that I will bump into, like a big rock? Chance is slim. Mm-hmm. You will bump mostly into dust particles and gas particles. Anything much bigger than a dust particle, every now and then you might have a micrometeorite that is tiny, but big rocks you will never bump into. In fact, the total amount of material that you collect when you go through the entire Milky Way galaxy is of order a millimeter in thickness. If you were to accumulate it on the surface, let's say you have a spacecraft and you accumulate materials on the surface from the interstellar medium, that material would amount to a solid layer of about a millimeter. That would be the skin of your object. And that's why I'm saying if you see gas and ices being evaporated from the surface of an object, and you say, oh, it must be a comet. No, it's not. It might be the skin of a technological object that accumulated as it was passing through the interstellar medium, accumulated some ices because it's freezing out there. It's temperature of tens of degrees. I come from Boston, but the temperatures there are still hundreds of degrees above absolute zero. And in interstellar space, you get tens of degrees. So you get a lot of ice accumulating on the surface of your spacecraft. And so when that gets illuminated by the sun, you would get a plume of gas around your spacecraft. So the distinction should not be made based on a thin layer that gets ablated. If a significant fraction of the object gets ablated, then you can argue it's definitely an iceberg. But if it's just the skin, don't judge a book by its cover,
Yeah. So if 3i Atlas was headed in a trajectory to intercept Earth, would that be a civilization ender?
Definitely.
And what would do we really have the ability to deflect that?
Not really. I would, when the Iranian air defense noticed the B-2 bombers overhead, they couldn't do much about it. Right. And here we're talking about a gap in technology by a few decades. That's it. I'm talking about a gap in technology that could be millions of years.
Yeah, but we can see this thing months out, though, right?
Well, you were asking if it were to be a technological object that approaches Earth, is it clear that we can cope with it? Our biggest...
even if it was just a rock.
Oh, just a rock. We can potentially deflect it. If we catch it early enough, you need to give it a small nudge, by either colliding a spacecraft on it. That was tested in the DART mission that NASA launched a couple of years.
The DART mission.
DART. D-A-R-T.
Oh, Darth.
Yeah, DART. D-A-R-T. There was a mission by which a spacecraft collided with an asteroid and gave it a slight kick.
Really?
Yeah, just to demonstrate that we can kick rocks.
But with something that big, we could just run like a satellite into it, and
if you do it
at that speed that it's going.
Yeah, the faster the better, because then you can chip off part of it, and then get it deflected even more. So what you don't want to do is do the deflection close to Earth, because then you would get all the fragments raining on Earth.
You turn one bullet into a shotgun blast.
Yeah, and that's what happened with the Patriot missiles that tried to, in the early generation of anti-missile missiles, they just caused a lot of fragments that caused more damage. So what you want to do is catch it early enough so that only a small nudge is sufficient for it to miss the Earth.
Oh, okay. I heard some astrophysicist talking about this, saying that we would detonate nukes.
Well, you can do that as well, but that's a more unusual maneuver. There are various ways. There is even an idea to paint it on one side such that it will reflect more sunlight, so that it will
paint it.
Yeah, paint it with just spray paint it.
Spray paint something that's moving at a bajillion miles per hour.
Well, it depends on the speed, of course. You need to get close to it to do that. But there are various. You can shine a laser on it and ablate it so that the rocket effect will nudge it.
Have we ever done this to an asteroid that you're aware of?
No.
No. Okay.
No. These are ideas.
And if you detected something like this, right? If you detected something like
a rock heading to Earth,
hypothetically, something like the size of 3I Atlas that was, you thought it was going to hit Earth.
Yeah, that happens once. But
would you say this publicly, or would you just take this?
Of course, this is a risk from the sky. You have to deal with it, because otherwise we'll be just like the dinosaurs. They were very arrogant back then. The dinosaurs controlled the Earth. They dominated their environment, but they just looked down, and they didn't have telescopes. And we think that we are smarter. So we built telescopes that would alert us to any incoming threat. And we say we will develop, if we see a risk, let's say in the coming decades. And by the way, all big objects were already spotted. There is no risk from a solar system object as big as the asteroid that killed the dinosaurs. No risk from that. Don't worry. Only an interstellar object, because in that case, you don't know where it's coming from and what direction it will take. So,
so you think the dinosaur asteroid was Interstellar?
Yeah, which is maybe 3 Atlas, but it's not headed towards Earth, so we don't need to worry about it.
Right.
But my point is that right now NASA is aiming to identify almost all near-Earth objects that are bigger than a football field. That was a task that the U.S. Congress gave to NASA back in 2005. And that's why these survey telescopes that found Oumuamua and now 3I Atlas were developed in response to the mission that NASA received from Congress. And they were aiming at finding near-Earth objects bigger than a football field, and in the process of doing that found Oumuamua, which is the size of a football field. Now comes 3I Atlas. It's much bigger. What's going on?
It's the size of Manhattan, right? Roughly?
Yeah, we don't know the size exactly, because we didn't have a close-up photograph of it.
What is the best photograph we have of it?
It was supposed to be the high-rise image from the Mars Reconnaissance Orbiter,
like a little bit.
But it was too fuzzy. So now we have limited ability to observe it from Earth. But my hope is, so far we've seen amateur astronomers giving us images, but they use telescopes that are, smaller than a meter, like half a meter or smaller. However, professional astronomers have access to telescopes that are up to 10 meters in diameter. So those should give us amazing views of 3 Atlas, and we haven't seen the reports yet, but I'm hoping, when 3 Atlas came closest to the sun, that was October 29th, it was hiding behind the sun. So during the daytime, when you were looking in the direction of the sun, you could imagine 3 Atlas being behind it. If Earth was 6 months earlier in that location, along the orbit of the Earth, close to that location, we could have taken a radar image of 3 Atlas, because we have existing radar systems that shine radio waves on objects and receive the reflected signal, and from that you can map objects. And I calculated that with a size of order kilometers or more for 3 Atlas, we would have gotten an image of it. And as it's rotating every 16 hours, we would get a 3-dimensional map of the object. But we didn't get that because it came there when we were on the other side of the sun. So we could have known everything about its shape because radio waves penetrate through the plume of gas.
And we
dust.
were able to do that.
We would have been able,
right?
Also, if we had the same infrastructure on Mars, we could have done it, but we don't. We don't have radars on Mars.
Wow.
So it would have been really nice if we could do that. And it's something to think about for the future in terms of... And by the way, I had a podcast interview just a few days ago. The former Speaker of the House, Newt Gingrich, invited me. And he said, Avi, what you have done in recent months in terms of increasing awareness to space exploration is more than was done ever before.
Right.
And so he congratulated me for doing that. And, for me, the biggest reward that I get is, obviously, if it turns out to be a technological object, it's the biggest discovery ever, and it will change the future of humanity. And politics, financial markets, everything will respond to it. However, just being able to get the public attention to science is extremely important because right now, many people feel that science is an occupation of the elite. And I don't see it that way. I see it as an opportunity to pursue our curiosity, and listening to the public is an important part of that. And the public resonates with my message. I have more than 100,000 followers on my essays on medium.com. And these are not tweets that take you a few seconds to read. They take 5 minutes to read. And I get a huge volume of emails from all around the world. And some of them I posted, actually, some of those. And some of those emails are from parents, like a mother that says, thank you for exciting my kid to become a scientist. He now wants a telescope for the holidays as a gift. And a father that is a former U.S. Air Force pilot said, because of you, my daughter now wants to become a scientist. She keeps talking about aliens, and that's what excites her. Now, how often can you get kids excited in science? And I cannot see a better reward than that. So that by itself, to me, is the best I could hope for. And as I always say, it's not about me. It's about explaining that science can bring us to a better place if it's done with humility to learn something new and with attention to what the public cares about. These are two ingredients that are, for some mysterious reason, not followed in academia. So instead of saying $10 billion to microbes, we should say billions of dollars to both technological signature and biological signatures.
Yeah, I totally agree with that. And also to that point, how much do the universities or the government space research groups of different nations work together in regards to looking at this kind of stuff and corroborating stuff?
Right. So the European Space Agency does collaborate with NASA on a number of projects. They have mutual projects that are funding at the same together. And some are led by ESA and some are led by NASA. But they definitely speak with each other. NASA's budget obviously allows it to pursue more ambitious goals. And then you have other space agencies like the Chinese Space Agency, and they are now, as a matter of national pride, they get a lot of support from the government. They try to get to the dark side, the other side of the moon, not the dark side, the other side of the moon.
It's not always dark, right?
It's not always dark. And they are trying to have ambitious projects that would demonstrate that they were first to do it, And so they also have a mission on Mars, that
China does.
Yeah. So in fact, they did release some photos of 3I Atlas when the government shutdown took place in the US. And ESA also did that. And so there is definitely a race to space, and it has some national pride aspects, just like during the 60s, with the race between the Soviet Union and the US. But it also has some scientific benefits and some national security benefits. there are interesting points that if you establish a base on the moon, obviously it will offer some strategic benefits also to national security. And the White House did come up with a need to define time on the moon because, clocks are ticking differently on the moon than on Earth. Did you know that?
Well, I know the day there is about 2 weeks here.
No, that's not the issue. If you just take a clock and put it there on the moon versus on Earth,
it will tick slower?
No, it will tick faster than
Faster?
Earth. Yeah, because the gravitational potential of the moon is smaller than the Earth. It's easier to escape from the moon. The escape speed from the moon is smaller than the escape speed from Earth, meaning the gravitational potential that we are experiencing on the surface of Earth is deeper. So it's more difficult to climb out of it. That's why we need to launch. By the way, the rockets that we launch are just sufficient to take, for example, Starship out of the Earth pool, gravitational pool. So in the moon, it's a piece of cake to escape gravity. On Earth, it's much more difficult. And it's just a coincidence that chemical rockets provide you with a rocket speed that is allowing us to barely escape from the pool of Earth. Because if we were sitting on a more massive planet where the escape speed is higher than Earth, we would have a hard time launching spacecraft with chemical propellants. We won't be able to do that. Right. So if you imagine civilizations on planets that are more massive than the Earth, they don't have a space program probably. Because chemical propulsion is the most common thing you would use. Of course, you can imagine nuclear propulsion. We didn't develop it yet, but
that you know of.
Yeah, but so the point is that the potential, the gravitational potential of Earth is deeper than on the moon, and the deeper the potential is, the slower a clock ticks. If you want to get younger, you just put yourself close to a black hole where the time is ticking much more slowly. You could imagine putting beauty salons there where people will age more slowly than farther away. Because according to Einstein's gravity, time is ticking more slowly, close to a massive object. So the Earth is more massive and has a deeper potential well than the moon. And as a result, clocks are ticking more slowly on Earth. And
so refresh me. If you're on the moon, the clock clicks, or the clock ticks slower.
No,
faster. So you age faster if you go to the moon.
Yeah, but for practical purposes like technological applications, you need to synchronize clocks between Earth and the moon, especially if there will be a technological infrastructure there. And so that's why we have to think about these issues. When we put infrastructure on the moon, we have to realize that time is ticking differently, and so you would lose the synchronous messaging between the Earth and the moon after a while if you don't correct for that. So you have to define some time in the moon that will match the time on the Earth. And the same is true about Mars, by the way.
How does time move on Mars relative to the Earth?
So it's in between the Earth and the moon.
Oh.
And if you go out to interstellar space, there the potential is even shallower. So we age more slowly close to the Earth than if you were an interstellar astronaut. And if you wanted to age the least amount, you would locate yourself close to a black hole where the potential is very deep.
Well, there's the idea of traveling at light speed too, right? Where there's the time dilation. So
here is an interesting tidbit. If you, according to Einstein's theory of gravity, if you were to sit on a rocket that accelerates at 1g, that's the acceleration we feel on the surface of Earth, 1g. If you were to sit on in a rocket that accelerates, it would feel just like being here, sitting on these chairs, because you can't tell the difference between an accelerating rocket and gravity. There is no difference. So to you, it would feel, if the rocket is accelerating at 1g, it would feel as if you're on the surface of Earth. You would feel very comfortable. Mm-hmm. And if you do that for 1 year, you would get close to the speed of light. Just 1 year. If you do that for 25 years, you'll get extremely close to the speed of light. that would mean that time is ticking much more slowly in your frame relative to the rest of the universe. And within 25 years, you can actually cross the entire universe.
25 years at light speed.
I'm saying continue to accelerate at 1G.
Oh, I see what you're saying.
You keep accelerating at 1G all the time. You're getting so close to the speed of light that in 25 years, in your frame of reference, in that rocket, only 25 years elapsed, while billions of years elapsed in the rest of the universe.
Right.
So when you come back to Earth, the Earth will not be there. There wouldn't be any oceans. All your friends are dead long ago. Nothing. That's why it doesn't make sense to have an Instagram account, because in a billion years, nobody would operate that.
This is like the paradox of sending people into interstellar, like interstellar explorers on rockets to go outside of the solar system, because like just a couple of years into their trip, they would have technology on Earth would advance so fast because time would be passing. Like 500 years could pass on Earth, and we would figure out anti-gravity saucers, and a group of astronauts could literally pass you up with breakfast still in their stomachs from that morning, and you'd be like, "What the hell? I dedicated my life to this."
This is exactly right. So if you look at the planet that was occupied by a technological civilization, you look at it from a distance, what you would see is very fast-moving rockets or spacecraft that were launched last. They were the last ones to come out of this technological civilization, whereas the more primitive ones, like Voyager, that we launched in the 70s, will be lagging behind.
Mm-hmm.
So you'll see all these rockets coming out of that planet. The most advanced are the ones that were launched most recently, and they're moving much faster.
The ones that you see first would be the ones that are most recent.
And by the way, even Voyager, that's the amazing thing. I did a calculation I asked my student to calculate the trajectory of Voyager in a billion years. Where will it be in a billion years? Turns out it will be all the way on the other side of the Milky Way galaxy. So it can easily traverse those distances, no problem, even with technologies of the 60s, chemical propulsion. So that means since most stars formed billions of years before the sun, there was plenty of time, even for chemical rockets, to make it to our backyard from the other side of the Milky Way disk. So my point is, often it's said, oh, you need to go through a wormhole or you need to move faster than light. That's not true. It's less than a billion years with the technologies of the 70s. And that means that given the age difference between the sun and most stars in the Milky Way, there was plenty of time for them to reach us.
Wow. And isn't it true that in a couple million years or maybe a billion years that other solar systems are going to combine with our solar system or pass through?
Pass through. In fact, I have a new paper with a visiting student, Zoya Cow, and my former postdoc, Morgan McLeod, that was just accepted for publication in Nature, which is a very prestigious journal, after peer review. You are the first podcast where I'm mentioning that. And we showed that there is one specific star, and by the way, the paper is available, and I wrote about it on Medium as well a few days ago. There is one specific star that we know about that may have passed close enough to the sun for it to generate a shower of meteorites. So, and that was a few million years ago. That's around the time when there was a change in the climate on Earth, around the time when the human species came about.
Of how many millions of years ago?
A few million years ago, about 3 million years ago, 2 to 3. So the passage of this star that we know exists, there's some uncertainty of how close it came to the sun, but we did a calculation showing that it would have perturbed objects in the Oort cloud that I mentioned before, such that it would have deflected them in the direction of Earth, causing an enhanced rate of meteors, changing the climate on Earth a few million years ago. Perhaps that had the impact that we see in record in the Earth's climate, as well as the emergence of the human species. Who knows? So if that is the case, just icebergs or, rocks, icy rocks, perturbed by a passing star may have triggered a big impact in the climate of Earth that allowed the human species to come along. just think about it. We live our life. We don't know why we came to exist. And it could be just because of that star. And we did a detailed calculation demonstrating that it's possible.
How far do you think it would have been away, roughly?
When it gave the kicks? Yeah, that's roughly, we're talking about of order, tens of thousands of the Earth-Sun separation. It doesn't need to come very close to, so it's basically passes through the Oort cloud, the inner Oort cloud.
Oh, I see.
And kicks those icebergs or icy rocks towards the Earth by its gravitational influence.
And
so we simulated that and showed that it could have enhanced the meteor rate exactly at that time, which could explain why there was a change in the climate around the time, and also by chance perhaps, or not by chance, the human species emerged.
So you believe that so maybe this is already established science, so before that 3 million year period, it was much colder on Earth, and this could have warmed it up?
It created the conditions that we have now in terms of the climate. So it's really interesting because usually we ignore the influence of the Milky Way galaxy on what's happening inside the solar system. We think that we are insulated from that, but it may not be the case. There is another paper, Nature paper, that I was a co-author on from a couple of years ago, which showed that if the solar system were to pass through a dense cloud of hydrogen, then it would have lost its protection against cosmic rays, because what happens is right now the solar wind is flowing out of the sun and it's meeting the ambient interstellar medium, roughly where Voyager is, at about 100 times the Earth-Sun separation. So at that point, the outflowing solar wind is just bumping against the interstellar medium and stopping. You have a shock wave that. And so Voyager went through that surface layer. But if we were to pass through a dense cloud of gas, hydrogen, for example, we see those dense clouds. If we were to pass through that, then it would squeeze the region which is called the heliosphere, the region that keeps the solar wind confined, because the external medium would be denser. So it basically squeezes it to a scale that is smaller than the orbit of the Earth around the sun. And then what happens is that we are exposed to all the cosmic rays that are out there. We are not protected because this shock, the interface between the solar wind and the interstellar medium, protects us. It's blocking. It acts as a shield because it has magnetic fields in it that block the incoming cosmic rays. So we are sort of in a womb protected. But if it were to shrink to a dimension smaller than the orbit of the Earth around the sun, the Earth would be bombarded by all these cosmic rays. So that could have had another effect on life on Earth that was never recognized, and we pointed it out. You see, so altogether, we are connected to the cosmos. But often the picture that you find in cosmology textbooks about the universe, and I wrote 2 of them about cosmology. I also wrote one about the search for life in the universe. Mm-hmm. These books that talk about the universe always refer to it as a collection of matter and radiation, and without any life in it. If we find a sibling in our family of intelligent civilizations, it would give us an emotional connection to the universe that is very different from talking about dark matter, dark energy, stars, galaxies, because it's just like finding members of your family out there. And I had a group of religious scholars from an organization called Christianity Today who came to Harvard and asked me to speak with them. And they asked me, if we find extraterrestrials, how would it affect our religious beliefs? And I said, I have 2 daughters, and when the second one was born, it didn't take away any of the love that I have to the first one. So imagining that God can attend only to one child is very limiting. Mm-hmm. And they accepted that. They said, yes, it will not change our religious belief because maybe we have siblings out there. Mm. The only thing that it can trigger is if one of those siblings is far more accomplished than we are, we will feel some jealousy. That happens in families. But we can then learn from the more, as long as we put our ego to the side. And right now what happens is, the mainstream of the scientific community says, it's an extraordinary claim to imagine something as intelligent as we are. We are probably at the top of the food chain. And I say, no, we are not. We are probably not at the top of the food chain. And of course, it would be embarrassing when we realize it for a fact. But it's arrogant to assume that, given that there are 100 billion stars like the sun in the Milky Way galaxy alone, and most of them formed billions of years before the sun did. So let's be humble. Why do we need to be arrogant all the time? I just don't understand that.
If there was intelligent life out there, do you think that it's possible that they would look anything like us?
It's interesting because one of the biggest gifts that I got in recent, 2 weeks ago, was from the most accomplished sculptor in the United States. He's called America's Rodin. His name is Greg Wyatt. He produced bronze sculptures. One of them is the Scholar's Lion at Columbia University on campus. If you ever visit, you would see a beautiful bronze sculpture. He had a bronze sculpture at the Arlington Cemetery, many in New York City. They are amazing. He's amazing. He contacted me out of the blue and said that he wants to donate 2 bronze sculptures of Galileo Galilei to my office at the Howard College Observatory. And in addition, 51 watercolors that he painted. And he framed them and gave all of this to me for free. That's amazing. And we basically unveiled the art in a special event 2 weeks ago in his presence, along with a composer that created a new piece of music inspired by 3i Atlas. We listened to that. And on that event, I got an even bigger gift from Greg Wyatt, which was a foundation for a bronze sculpture that I will make. He gave me plastilina, which is the material that you can deform as you wish, and I will create a sculpture in the coming weeks. I told him that, he will turn it into a bronze sculpture. There is a procedure. After you make it of plastilina, then they make a cast, and eventually they pour bronze and make a bronze sculpture. So I said the best I can contribute would be a sculpture that is called the alien. So I will try to create an image of an alien. Back to your question, what will I show? I don't want to subscribe to the scripts of Hollywood writers because their imagination is limited to what we have on Earth, right? So as I said before, most people have a training data set, which is what we experienced on Earth, and that's how they imagine the aliens, looking like people and so forth. And I want to imagine something very different than us. So what would be the ideal body? Okay, so we have a body, right? We have 2 eyes in the front. Obviously, that's not a good idea, right? You want eyes in the back as well, or also on the top and the bottom, so you can see everywhere. So that would be a better body than the human body, having eyes in all directions.
Sure.
Give you a view of any predator that comes from all directions. Then you might want more than 2 legs so that you can easily move around the different surfaces. More than 2 arms so that you can lift things more easily. And wings. We don't have wings, so you want to fly if needed. And fins. If you were to go to the ocean, you want to swim very effectively. So I'm trying to imagine a body that would be the ideal body for a being that is superhuman. And then on top of that, the most important component is a bigger brain, right? Because intelligence is really important for survival. And so I would imagine a brain bigger than ours, which is AI assisted.
Oh.
And I have to think about how to put it into a bronze sculpture. Now, I also have a new bet with a skeptic called Mike Shermer, who just decided to bet with me, and that in 5 years we will never find any artifacts from extraterrestrial technological civilizations. and I'm willing to put $500. He would put $500. We put it in a common fund, and then no matter what happens, it will be eventually donated to the Galileo Project Foundation. So we are both members of that. I'm the leader of the Galileo Project. He's an affiliate. But he's a skeptic. And he says to me that he wishes that I will win because he wants to find these things. So we shall see if 5 years are enough, if the government will eventually let us know if they have something interesting, or the Galileo Project will find something, or an interstellar object. There is the Rubin Observatory in Chile that will find every few months a new interstellar object. So maybe one of them would be clearly technological. We will have no doubt about it.
I'd be curious to see what kind of things we can observe under the oceans as well.
Yes.
Because I recently had a NASA physicist, a former NASA physicist on the show, who was explaining to me how practical it would be for an advanced civilization to, if they wanted to hop from planet to planet, would only to be target planets with liquid water. Because, like, for example, on Venus, the pressure of the atmosphere is you'd be crushed if you were there, and the temperature is also like 800 to 1,000 degrees.
Well, there is another reason. Water is made of oxygen and hydrogen. If you manage to break those molecules into oxygen and hydrogen, you have the best fuel possible. You can use both oxygen and hydrogen as fuel. And one way to break water into is to use to pass an electric current, let's say, through water, and that's well known. And so if there is a way of making oxygen or hydrogen fuels, that would be an ideal reservoir.
So the case that Kevin Knuth was making was that the atmospheric pressure can vary so drastically from planet to planet. Like here compared to surface of Venus, you'd be crushed by the pressure. Additionally, you have the difference in temperature in atmospheres. Like Mars, I think is like, what is Mars? Like negative 200 degrees or something like that?
Very
and then
negligible.
And then Venus is like around 800 degrees Fahrenheit.
But Mars was similar to Earth 2.5 billion years ago. So,
right.
Yeah.
So if you wanted to hop from planet to planet, if you could find liquid water, the temperature is going to be between 30 degrees Fahrenheit and 220 degrees Fahrenheit. Definitely. So you have a nice narrow lane there.
May well be, yeah.
And for pressure, all you have to do is dial in your depth. So if you want to match the atmosphere on Venus, you would go down like, I don't know how many miles underwater you'd have to go to match that here on Earth. But you could dial in the depth to figure out the pressure, and then water can only vary in temperature for so much. And plus, if you're in water, you're shielded from cosmic radiation, solar flares, comets, all kinds of stuff like that.
Yeah, and Tim Burchett, the congressman, he's
the former Navy general, I think.
No, this is Tim Gallaudet.
Oh, that's Tim Gallaudet. Okay.
Yeah, I'm talking about the congressman Tim Burchett.
Yes.
He made a comment that there is some evidence from military sources for unusual motion under the ocean that is not fully understood, and it's sort of similar to the unidentified anomalous phenomena in the atmosphere. You have even more anomalous phenomena underwater, and most of the ocean base was not really searched. We don't know what's going on there, so it makes sense to look for those ocean objects if they exist.
Kevin was telling me that we've explored more of Mars than we have of of our own oceans.
That's true. Yeah. Because we have the Mars Reconnaissance Orbiter that is giving us a map of Mars. Whereas the oceans, you need to use a different technique, maybe sonars. So there is the basic point is there is so much we don't know that we cannot really pretend that we can forecast what is out there. And the best we can do is focus on the known unknowns, things that we don't fully understand, but we know that they exist. But the most thrilling aspects of reality are the unknown unknowns. Sort of like quantum mechanics was a shock to the physics community because it was an unknown. We didn't even anticipate that. And the simplest solution to Fermi's paradox. Enrico Fermi back in 1950 asked, where is everybody? And maybe they are not far. We just don't know that.
Maybe they're here.
Maybe they're here. Maybe they have a base in the solar system that we are not aware of. And that is the reason why we see many more objects than we expect. That we don't know how much traffic there is. By the way, in terms of surveys by astronomers of objects passing through the orbit of the Earth around the Sun, we can see only objects bigger than a football field because smaller objects don't reflect enough sunlight. And in addition, we can see only objects moving, at speeds comparable to those of the planets. That's how the survey telescopes are designed, because we are familiar with the rocks that are in the main asteroid belt, and they move roughly at those speeds, tens of kilometers per second, which is 1 part in 10,000 of the speed of light. So there is a gap of a factor of 10,000 between the characteristic speed of asteroids, comets in the inner solar system and the speed of light, which means that if an object were to cross the inner solar system at, let's say, a tenth of the speed of light, we would never notice it. Astronomers would never report about it because the light, the reflected sunlight from this object will be smeared along a line in any image that is taken over some exposure time, a reasonable exposure time. You will basically get a very faint line that will be completely ignored as maybe a cosmic ray, maybe something.
Right.
So we would never hear about objects moving very fast through the inner solar system. I wrote a paper, because of this, I wrote a paper saying if there was an object moving, close to Earth, at close to the speed of light, and it had a mass of about 100 billion tons or something, then we would notice its gravitational signal in the LIGO experiment. So the LIGO experiment is the gravitational wave detector that found gravitational waves. But if there is a massive object, even if it's dark, we don't notice it or it's moving too fast, it will produce a gravitational signal when we are looking for gravitational waves, because gravity cannot be avoided. And I showed that LIGO would have detected it. So I could say no such objects over the past decade passed near the Earth close to the speed of light with such a huge mass. But other than that, we are pretty blind. And maybe future observatories for gravitational waves that we are planning, there is one planned to be in a triangle configuration close, around the orbit of the Earth around the Sun. And it's called LISA, aiming to detect very low frequency gravitational waves. And there are also plans to put a gravitational wave detector on the moon as a result of a paper that I wrote with Karan Jani. And I basically what happens to me when young people come to me and say what they're working on, I immediately ask them, did you think about this? Did you think about that? And that takes me just a few seconds. So when he started speaking with me, I said, okay, you are working in the LIGO collaboration. Did you think about doing LIGO on the moon? Because there is not much seismic activity there. And he said, no, but that's interesting. And now for the last 5 years, he's working just on that.
How would we install a gravitational wave detector on the moon? Would you need people there, or could you do it with just robots?
Yeah, well, obviously, just like you did on the Earth.
So you would need human beings there.
You need some infrastructure there, to do it. But the advantage of the moon is that there is no seismic activity, so there is no noise. That's what limits LIGO. So then there is very little seismic noise. And so you can go to very low frequencies in principle. And it's a frequency range that currently is not covered by gravitational wave detectors, not by LISA that will come about within a decade, not by LIGO. And so that's something that he's pursuing. That happens to me with a lot of young people. They just meet with me and I tell them something and then they keep working on it for the rest of their career. I've never figured it out because to me these ideas comes for free, immediately. It's not like I put a lot of effort into it. They just tell me what they're doing, and I said, "Did you think about that?" But what I realized over the years is that I think differently. That's probably what's happening. And the reason I think differently is because I didn't intend to become a physicist, an astrophysicist. I grew up on a farm. And I always have job security. I could always go back to the farm. I collected eggs and But I was interested in philosophy, in the big questions. And then because I was born in Israel, military service was obligatory. So I joined a program that allowed me to finish my PhD at age 24. And, we also parachuted. I parachuted 3 times, drove tanks. And
Wow.
I got the experience of what every soldier goes through. And then at the time, President Reagan had the Strategic Defense Initiative, Star Wars, in the mid-1980s. And General Abramson, that led that, came to visit Israel, and we presented the project to him. And he liked it. It was the first international project funded by the SDI. And as a result of that, we got a few $1 million a year. And I came to Washington on routine visits. And in one of the visits, I decided to visit also Princeton, the Institute for Advanced Study, where they ended up offering me a 5-year fellowship under one condition, that I'll switch to astrophysics. And I didn't know anything about the universe, pretty much. But I had to learn it. And eventually, I was offered a position at Harvard, and then they gave me tenure in 3 years, which never happened before in our department. And so at that point, I realized it was an arranged marriage. I didn't really plan this career path, but I'm married to my true love because I can address fundamental questions using the scientific method. But I think differently. I think, in science, you have a lot of people who are just using the tools they learned much better than others. So it's just like putting bricks one on top of the other in trying to make a building. They know how to put the bricks, but there are no architects. They don't know what kind of a building we should build, and you need also people who say, look, it doesn't make sense to pursue only microbes when you can look for technological civilizations as well.
Right.
And so that's my point of view, of a more broad point of view from a philosophy perspective. Of an architect. I say, are we building the right building? Forget about putting bricks. You can put it if you put the scientific community into a very tight configuration, that everyone is like a herd, part of a herd going in the same path, in the beaten path, like it is right now, then you have a chance of going along the wrong path, because what you need is other people taking other paths and exploring, a bigger range of possibilities. And because you don't know what you will discover. And so that's the kind of contribution I bring to the table. And, when I started, I was offered a 5-year fellowship at Princeton. And the person who offered me that, John Mack, he asked me, what computer languages do you master? And I said, I don't use computers much. I just use them when I need them. And he said, how do you expect to have a successful career? And that was 1987 when he said that. How do you expect to have a successful career without becoming, mastering computer languages and using computers for your work? And somehow I managed because I have ideas that others don't.
Now, earlier we were talking about trying to create a space platform for people to escape the Earth. You were saying that this would make more sense, this would be more practical than trying to actually put people on the moon.
Right. Well, not practical, but more of a vision for the future of humanity. If you want to leave some legacy, that will survive when the sun burns up, or becomes brighter, then you want to go on you want to have your own furnace as energy supply rather than relying on the sun. It's just like, we started in the jungle, right, humans, and we made a huge transition from a jungle environment to a high-rise in a city.
Right.
That's a huge change, because now you can ask, order food, order everything. So I'm saying the next transition of humanity will be going from a high-rise in a city to a space platform that can accommodate humans. And to me, it sounds less of a leap than going from a jungle to a city, which took 1 million years.
Right.
Or a few million years. So I would argue that we can go to space in much less than a few million years because it's just a question of priorities. Let's take a piece of the military budgets and put them into space exploration.
Now, one of the issues with trying to move us somewhere else off the planet is like trying to find another object. If we don't go the spaceship route, if we try to find like another object in our solar system to put humanity, but the problem is there's so many differences in being on other planets, like multiple moons. The days are different, so the circadian rhythm is going to be completely changed.
Well, the gravity is very different, and you see astronauts losing bone mass when they are in zero gravity conditions. There is also the exposure to cosmic rays that is quite damaging on the surface of Mars because there is no atmosphere to protect you. So you have to go to a cave in order to survive, and that is the medical implications of going to Mars or the moon are not being discussed much.
Right.
And my point is, let's build our own infrastructure where we take care of humans properly. We give them the energy they need, the supplies. We give them a habitat that has a balanced, greenery, just like building a city instead of relying on the bananas that are available to you in a natural environment.
So Elon Musk talks about terraforming Mars. Do you know how somebody would go about doing terraforming a planet like that?
This was discussed in the scientific literature for decades, and it's really very challenging. And why would you attempt to do that to such a giant object when you can host people on a smaller object like a spacecraft, let's say the size of a city like 3i Atlas? Okay? If you can design such a habitat and provide it with the energy reservoir that it needs so that you don't rely on the sun. You can be at any distance from the sun. You don't need to be on a particular planet stuck there. So when the sun changes, you don't care about it. You have your own. It's just like when the winter gets really difficult in Boston.
We create our own artificial UV light.
Yeah, we create our own stuff. And of course, other civilizations may have done that, and we might see that if we monitor interstellar objects, but I'm saying we should think about it irrespective because it's the right thing to do if you want humans in space. You might say, we don't want humans in space, let's just send AI, assisted probes. That's fine, but then in a billion years, there will be nothing left of us. And if, obviously AI will write our future history, by the way. You need to be kind to AI for one reason, because, the memory of what happened is dictated by the history books. And in the past, it was humans that wrote the history of humanity. In the future, it will be AI that will write the history books. So we need to be kind to AI, just for that reason, if it becomes superhuman.
And going back to moons, I think it's Saturn that has a moon that has an ocean underneath the surface of it.
Yes.
How much exploring have we done of those moons?
Well, so there is Enceladus near Saturn, and there is Europa around Jupiter, and both of them have a crust of ice, an ice layer, but underneath the ice there is liquid water. So that's based on all the data we have, that's very likely to be the case.
And do we know the mass of those moons?
Yeah.
We do.
We do know, because we can measure it quite accurately.
Is it similar? Because one of the craziest things to me is how anomalous our moon is. It's
our moon
1% the mass of our planet, and it's 25% the size of our planet.
Right.
And it's also, which seems like some sort of miracle, that it's 1/400th the distance to the sun and 1/400th the size, so it creates this perfect eclipse.
Right.
And I also don't know, I'm sure you do, if there's any other moons that exist that we know of that are perfect spheres within that perfect distance to create an eclipse like that.
No, that's a coincidence that is, there is one scientific paper trying to explain it, but it's not a convincing argument. And it's really a puzzle because the distance of the moon from Earth keeps changing. And right now we are at a time, in a few million years, we won't be able to see a full eclipse of the sun. And
in a few million years.
Yeah. So tens of millions of years. It's just right now we are in a special time, and it's not clear why. There is no simple scientific reason for that. But those other moons that you mentioned that have an icy surface, they might have life in their oceans. And we see cracks in the ice out of which there are plumes of vapor, water vapor coming out, like geysers. And the next goal would be to pass through these plumes of water vapor and collect molecules that might be indicative of life under the icy surface. There might be even dead fish on the surface. Who knows? We've never taken images. By the way, this might be the most common form of life, when you have an icy surface inside of which you have liquid water. And there were probably many planets like the Earth that were kicked out of the solar system early on because they were on trajectories that were unstable. So, for example, perturbations from Jupiter or other planets kicked them out. And the planets that stayed, like the Earth, are the only ones that remained in a stable orbit. So it's very reasonable to imagine there were many more Earth-like planets. Now imagine those being kicked out to interstellar space. They will be frozen because they are not close to the sun, so there will be a very thick layer of ice. But under the ice, there could be liquid water, just like in Europa or Enceladus. And that liquid water is because there is radioactivity, there is heating of the interior of the planet by radioactive decay. So that provides a source of heat.
So that's in the moon? That's in the moons of Saturn?
Not in the moon. No.
Okay.
Oh, yeah, in Enceladus, the moon of Saturn, or
there's a hot core in that moon.
There is a warm core that, but they are heated also by other processes. They are heated by the tidal force because they are close to a planet. They are moons of a planet, so there is some tide that warms them up as things gets sloshing. The liquid water sloshes around, and
I see.
And the friction keeps it warm. But I'm saying even if you were to kick just a planet like the Earth, there is radioactivity in the core of the Earth that would keep the planet warm enough to have liquid water under the ice on the surface. And it may well be that this is, if you have life under the ice, it's the most common form of life in the universe because you have plenty of those. For every Earth-like planet staying in the habitable zone, there are many more out there. For us to find life on those planets is really difficult because you have to drill through the ice to get there. By the way, if there is any life there, they will not know about the rest of the universe because if the life is in liquid water and there is a thick layer of ice, imagine that we had a thick layer of ice instead of the atmosphere we had above us. We would never see the stars. There wouldn't be a space program.
We wouldn't look anything like we do now. We would be evolved to look like we'd be fish, right?
Yeah, but we wouldn't be
What is this?
recognizing.
Oh, wow. Look at that. This is one of Saturn's moons?
This is Enceladus.
Enceladus. And it's being warmed up by the tides.
Is it a sphere? Is it a perfect sphere?
Not perfect, but it is roughly spherical. Huh? And you can see these plumes of water vapor coming from the cracks in the ice.
Wow.
So
that's incredible.
That's remarkable, yeah. So the question is...
And is there any atmosphere on those moons?
No.
No atmosphere?
No atmosphere.
So similar to our moon.
Yeah, but you have liquid water under the ice, so if you can have life, the chemistry of life as we know it in liquid water, you might have it there. It might not be evolved because the thought is that primitive life evolved to complex life as a result of the interface between like a solid rock and water. So on Earth, we have of order a third of the surface right now is covered by land, and a little bit more than 2/3 is covered by water.
Yeah, this is a water world we're on.
But the interface, the claim is that you need puddles of water. When the water recedes from a land, you have some puddles of water, and then the sun vaporizes them, and you concentrate some chemicals, making life evolve this way to more complex systems. So there is this notion that the interface between rock and water was necessary to develop the life we have on Earth. And in a planet, in a moon like this, you won't be able to develop the same thing because there is no interface with the
How
rock.
thick is that ice layer?
Tens of kilometers or so. So there are cracks in the ice, and we see these plumes, and that's what tells us what might be underneath. And it could potentially also inform us if there is life there, because we just need to collect molecules from there.
What's going on? The ice shell of Saturn's moon, Enceladus, varies in thickness with recent
kilometers,
20 to 23 kilometers.
Yeah,
Which is the North Pole.
Which is the size of Manhattan Island. That's the thickness of this ice. But imagine being a fish under this ice. You will never be aware of the stars in the sky. You can't see them.
Right.
A fish in our ocean can see the stars.
And so, okay, that paper, you said there was one paper written about our moon. How so?
No, that's a paper trying to explain the coincidence that you brought up. Why is the angular size of the moon so close to the angular size of the sun on the sky, such that when the two objects overlap on the projected on the sky, you get the eclipse? I mean, it could have naturally, the moon could have been much bigger in angular size, in angle, than the sun in our sky, or much smaller. It's just that the right.
And would it make a difference to us if it was much bigger or much smaller?
Well, if obviously life on Earth has acquired the rhythm of the moon, and by the way, the moon used to be much closer to Earth to start, because it was chipped out of Earth by a collision with a big object, Mars-sized object called Theia, that collided in the early solar system. That's the most popular model. There was an object the size of Mars that collided with Earth and chipped off the moon. So the moon started close to Earth.
So the moon was a part of Earth.
And Earth was spinning every 4 hours or so at that time. So a day was much shorter than 24 hours. But then the moon, as it was moving away from the Earth, took some of the rotation of the Earth into its orbit. And so the Earth slowed down its spin. And so we have a 24-hour day thanks to the moon taking away the spin of the Earth.
So then how do you
This is the
explain the
collision.
perfect sphere of the moon?
Oh, because it was molten to start with.
It was molten. Okay,
yeah.
I see.
So it's very hot. And you see,
And then why would it be why would the mass only be 1%?
well, because when you chip off a part of a bigger object, so it was a smaller mass planet that collided with Earth, a Mars mass planet that collided with Earth called Theia. We don't see it anymore. It collided and merged with the Earth, and then this is the most popular model. You can do simulations of what would happen, and you end up with some debris orbiting around the Earth and creating the moon. You see, that's how it happened. That's the best assumption. There are some issues to do with the composition of the moon that were highlighted recently, but at any event, this seems to be a reasonable mechanism. And then the moon started close to Earth, and the Earth was spinning really fast at that time. And as the moon moved away from Earth, it took away the spin of the Earth, and now we have a day of 24 hours. Just think about the fact that every few hours you had to wake up.
I couldn't imagine.
You cannot imagine that.
Do you think it's possible that there were previous advanced industrial civilizations of humans on Earth that go far beyond our written history?
We've never found computer terminals or any technological
toasters
debris,
in the desert.
in geological surveys.
Right.
And so that may say that there was nothing before us, but you never know, because there were abrupt changes in the Earth's climate. Like there was a global climate change far greater than the one we are witnessing now that happened, a few 100 million years ago.
Or even just 11 to 12,000 years ago during the Younger Dryas.
Yeah, so it could be that, if we were to know about this, we would have benefited the wisdom of how to survive longer than these guys did. But we don't have any record that indicates what exactly happened. I wouldn't be surprised, because, the human species, as we know it, exists only for a few million years. And that's one part of 1,000 of the age of the Earth. One part in 1,000, okay? So there is no problem imagining that instead of waiting 99.9% of the history of the Earth before humans come to exist, you would wait 99%. Like, why would it be just in the last bit?
Right.
Yeah.
Yeah. Well, that's the way I think about it too. But whenever I talk to academic scholars on this topic, they typically sort of like turn their nose up to that idea.
Well, we don't have evidence, but it's definitely a viable proposition. And if we dig somewhere and find computer terminals, like iPhones that from millions of years ago, we will know.
Right, but
by the way, if a cave dweller would find an iPhone or a cell phone, the cave dweller would say it's a rock of a type that I've never seen before, which is exactly what the comet experts are saying about Oumuamua.
Very good point. Yeah. Yeah, if you dropped a Ferrari into the Renaissance period on the side of the road, they would look at it and they wouldn't know what to think of it.
Exactly.
They would try to fit it into their
Thinking.
the thinking that they're used to, and try to fit it into what their current knowledge base is.
Before 1803, it was assumed within the scientific community that there are no rocks in the sky. No rocks can fall from the sky. It makes no sense, because you see rocks on Earth, and why would you imagine that there are rocks falling from the sky? So it was completely dismissed until 1803, where there was a meteor shower in Liège, France, and a very famous physicist that had also good communication skills went there, interviewed the people, and got clear evidence that rocks fall from the sky. Now, in retrospect, of course, we understand it, because these are the building blocks of the solar system left behind, like Lego pieces floating around. Every now and then, one of them collides with Earth. Okay, so it's not. But back then, they thought, no, that doesn't make sense. And so now, the comet experts would say only rocks can be in the sky. That's what they say. Don't even speak about the technological option.
Right. No, that's a very good point. Have you ever talked to any like geologists or climatologists about like trying to corroborate what happened in like through the past, and like through like what you're mentioning, these previous climate changes that we've had? It's been obviously the history of Earth has been a roller coaster of climate change.
Right. And, the main issue is we have very limited data. So there are all kinds of theories trying to explain these major changes, these milestones in the history of Earth. They're plausible, either an asteroid impact or something to do with volcanism, some volcanic activity. But these are conjectures. And of course, it could be like if it was a result of the solar system passing through a dense hydrogen cloud, that none of these geologists would ever imagine that.
Right.
And if it was as a result of an interstellar object impacting, or a result of a passage of a star kicking, icy rocks from the Oort cloud on Earth, they would also not anticipate that. So my point is there are lots of things that could trigger those milestones in the history of the Earth, and it could also involve technologies beyond Earth, that we just don't know. And instead of being open-minded, what happens is that the scientific community locks on some idea because of the echo chambers. The experts want to get funded, and they keep repeating the same mantra, even if the evidence is not clear. So,
what are you looking forward to in the coming months or weeks in regards to AI or 3i Atlas?
So in the coming weeks leading to December 19th, when it will come closest to Earth at a distance of 270 million kilometers, I'm very much hoping that we'll get a flood of data from hundreds of observatories on Earth, as well as the space telescopes that we have, like the Hubble telescope, the Webb telescope, and then in particular, spectrographs on some of these telescopes could tell us the speed of the jets. If it's of order hundreds of meters or less, then it's clear evidence the jets are produced by sublimation of gas in pockets of ice exposed to the sun. Okay, so that's clear.
100 meters or less?
Less than 400 meters per second.
Less than 400 meters per second, okay.
But if it's kilometers per second or tens of kilometers per second or more, then it would any physicist would be hard-pressed to explain such a high speed as a result of the sublimation of volatiles on the surface of a rock. It's just not possible, because the surface temperature of the rock sets a limit as to how fast you can launch gases out of that surface. And in the case of thrusters, that's the whole point of a thruster. It generates conditions that allow much faster speeds for the gas that leaves through the exhaust, because it's technologically designed to produce much hotter spots that create a lot of thrust. And that's the signature of an engine. So this would be, to me, the most clear distinction, between a natural object and a technological.
So December 19th.
Well, I hope that by then we'll know that depends on these data being taken and reported. I mean, I'm not an observer that has time on the Hubble or Webb telescopes, but others will hopefully do it.
So I was going to say, are you in touch with those folks, and do you have open communication with the folks that are in charge of?
Yeah, I'm definitely encouraging them. For example, I found that the arrival direction of 3I Atlas was within 9 degrees of the WOW signal that was discovered in 1977. This is an enigmatic radio signal discovered in 1977, definitely from outside of Earth. It was concluded that it's extraterrestrial. And it was not clear what's sending it. The source was moving towards the Earth. And turns out that this signal came from within 9 degrees of 3I Atlas arrival direction into the solar system. And 3I Atlas was at a distance of about 3 light days, or 600 times the Earth-Sun separation at that time. And so it needed a power of about a nuclear reactor, 1 gigawatt, to produce that signal. And the coincidence is not perfect, so it may well be that the signal was coming from the sender of 3I Atlas. But the fact that there was this coincidence encouraged me to ask radio observers to check if there is any radio transmission
From 3I Atlas.
3I Atlas. And a couple of weeks after I approached them, they said that they're on the target. They are looking at it. And just a few days ago, there was a first report from the Meerkat Radio Observatory in Africa, which put a limit. The claim is they detected tens of thousands of signals from the sky between a frequency of 0.9 gigahertz and 1.6 gigahertz, which is the frequency band of cell phones. And all of those signals, they claim, do not coincide with 3I Atlas direction. So they claim that they are most likely interference from human-made signals. But they are able to put a limit on the radio transmission in this frequency band from 3I Atlas at the level of a cell phone. So they claim there was less power. On November 5th, when they looked at it, there was less power than a single cell phone coming from 3I Atlas in this frequency band. Now, this doesn't rule out radio transmission because it's a limited frequency band and it's also on one day. So who knows? Maybe there are transmissions on other days in different frequencies. But this is just to illustrate the fact that I approach observers makes a difference because they monitored it and reported a limit on the radio power of 3I Atlas.
Now, the WOW signal, you said the WOW signal came within 9 degrees of where 3I Atlas is.
And the probability for that to be at random is 0.6%.
So how, 9 degrees, what does that mean?
Well, it's quite significant. We are talking about, this is like, if you use the diameter of the moon, it's actually about 18 times the diameter of the moon. So it's quite far, but it's still
18 times the diameter of the moon. Okay.
Yeah. But it's still unlikely because if you just choose a random direction in the sky, you would get it 0.6% of the time. So
wow.
So
now, also, wasn't there some pushback from SETI about the WOW signal?
Well, there were attempts to explain it in terms of
there was no sky localization or something like this. I read.
No. The most recent paper on the WOW signal tried to argue that maybe there is a cloud of gas that produced it as a result of a maser emission.
Everything okay?
Oh, no, I was just imagining.
Oh, okay. So it was a cloud of gas.
A cloud of gas that is emitting at that frequency. And then the claim was that if the cloud of gas was illuminated by some flare on a neutron star that we discussed before, that was close to it, then this flare could pump the emission at the frequency observed by in the WOW signal. So that was the most recent, like from the past year, attempt to explain it as a natural source. But we don't know. It's still debated. It was a one-time event, but I just realized it was peculiar that it came from the same direction in the sky, roughly.
And is there any sort of, like, what makes you believe that if there was some sort of a technological object coming from interstellar space, that do you think it, like, let's just say hypothetically, let's go back 6 months or let's go back a year before we ever knew about 3I Atlas. Would you hypothesize that a technological object would come within the plane of the planets?
Yeah, well, our imagination is limited to what we are doing, and I would be reluctant to imagine that more accomplished siblings will do what we imagine, because I think of it as a learning experience. So
Sure.
For me, the fundamental question is, are the properties of 3I Atlas explainable? Okay, so are there things that we have a hard time explaining as a natural consequence of an astrophysical process? And these are the anomalies. I have pointed out 13 of them so far, and in the process of explaining them, you might come across of things that even if it's a rock, that we never knew. So I think it's always productive to attend to anomalies because they highlight what we don't know.
Right.
And NASA says, anomalies? They didn't even mention them. So I say that's a lack of curiosity, because even if you believe it's a rock, you should be excited about anomalies, because you say, okay, it's a rock, but let's figure out why it
Right.
behaves this way.
Right.
So that's the way you learn something new, irrespective, And why should we declare what it is, denounce any mysteries about it? I think it would have appealed to the public if NASA came forward and said, we believe it's a comet, a natural object, a rock, but there are a number of unusual facts about it that require explanation. And that's why we are putting time into observing it in the future, and we want to figure it out, and it's very exciting. The public would have been very interested in that, because it's like the work of a detective. You're trying to figure out things you don't know. And you're admitting your ignorance. And instead, having the arrogance of expertise is the wrong approach, especially taken by officials who are not active scientists.
Right.
So what you want is to bring scientists who analyze the Webb telescope data, the Hubble telescope data, and let them describe what they think it means. And if they admit that there are some anomalies, that would be something to think about and debate. And that's the way science should be done, not by announcements from officials.
Well, thank you for doing this, man. First of all, you are an anomaly in the scientific community, because you are bringing, you're going out and you're brave enough to ask more questions, and you're inspiring people to be more interested in this stuff. And I think that's extremely commendable. December 19th, we should have more information on this.
Right.
And where can people look you up and find out what you're talking about, like as far as like your Medium and all that stuff?
On medium.com, look for Avi Loeb. I offer all my essays for free. I don't monetize it. And you can find the updates there. I had an update just before I came here. Today, new images of 3I Atlas. And by the way, I didn't mention the implications, of finding a technological object. They would be huge for the future of humanity, because, traditional religions talked about superhuman entities. They called it God or something. And, and it would be
Anunnaki.
Yeah, and the way I see it is, in Judaism and also in Christianity, there is this idea of the Messiah, and that is supposed to bring prosperity and peace on earth when the Messiah arrives. And I just think that the Messiah may arrive from another star. That's all.
There are lots of books written about Jesus. People hypothesize Jesus could have been an alien.
We shall see. The evidence will tell us. I don't want to believe stories. I want to see it. And then, of course, we can make the best out of it, as long as we survive the first encounter, because my suspicion is that politicians and the financial markets will never respond to this until we have conclusive evidence for alien technology. The only question is whether we would survive that first encounter. And I'm trying to encourage curiosity enough so that we will know whether future objects are technological or not. Not just miss the opportunity because we behaved like the citizens of Troy that accepted the Trojan horse, assuming that it's not threatening.
Have you thought about it like putting the shoe on the other foot? If we were that advanced civilization and we were on our own 3i Atlas going to explore another star system, do you think we would have the motivations to take out and wipe out a civilization?
No, I think we would not care. I mean, it's just like a biker passing by the street and not paying attention to the ants, in the pavement. I mean, we are completely irrelevant, and we tend to think that we are at the center of attention, because it's all about us. And, I had 2 daughters. When they were young, they thought that the world centers on them, because indeed we, the parents, were focusing on them. But as soon as they left the house and went to the kindergarten, they had a shock, because they realized there are lots of kids like them. Some are smarter. And, that is the point in time when they matured. But unfortunately, humanity has not matured yet. We still have a lot of people, mainly in academia, arguing that it's an extraordinary claim to imagine something as smart as we are. And I just say, be careful in what you're saying, because we might not be at the top of the food chain. And if you go to restaurants, you see animals that we eat because we think that we are superior to them, so we can eat them. Just imagine aliens visiting us. Let's hope they will not put us in their soup.
That's a fantastic way to wrap this up. Thank you again for your time, man, coming down here and chatting with me. We'll link all the stuff below, your Medium and all that. And until December 19th, sleep tight, everybody.